Good morning, everyone. Our session will begin in 2 minutes. At this time, please make sure to silence all your digital devices. We will begin our session in 2 minutes. Thank you. Please welcome Product Manager at Google Cloud, Donald Clark.
We actually have anybody here at 9 a.m. on the last day of the conference. So I know the people here this morning really want to listen to this. And it's not just you haven't been back, and this was the first session that was warm and open. There's three of us today. We're going to talk you through what it means to us at Google Cloud to run a high-performance network. And I'm going to start off by covering the foundational layers, so the underlying aspects of how we plan and build and think about our network, and even about beyond the edges of our network in terms of performance and resilience. You may have seen this slide a few times already at Next 19, but we'll say it again. Google has built, owns, and operates one of the world's largest networks. This network is based on fiber that we have laid ourselves or with partners, and that we've lit ourselves, for the most part. And because of this, it enables us to offer predictable and resilient performance around the globe. You can see from the map here all the paths that we've spent around 20 years building, and annotated specifically are some of our submarine cable investments, dating back to 2010 with Unity, all the way through to investments that are coming on stream in the coming year. So this is the network that enables us to deliver billions of answers to search queries. This is the network that enables us to serve billions of hours of YouTube videos to users anywhere in the world. This is the network that allows us to replicate content and services between all of our custom-built Google data centers around the world. And critically, this is the same network that powers Google Cloud. What's interesting, though, in recent years is it's increasingly a network that has been shaped by the needs of you, our cloud customers and partners. Let's have a look at one example of this. Last year, we made some specific new route builds between Singapore and Sydney, and as a result of that, we cut effectively in half the latency between these two regions. Okay? It's not actually that feasible to get a much lower latency now between Singapore and Sydney than we have on this route. And we're doubling down. on our capacity and resilience in this region with our investments in the Indigo cable systems and the JGA cable systems. And it's worth also to remark at this point that Google is now of a stage and of a size that we can build our own submarine cable systems by ourselves. These things are called private cables in industry parlance. And what that means is we can, without having to work or be slowed down with consortia partners in other cable aspects or cable investments, we can decide where we want to build it, and we can move very quickly. So it enables us to respond to growing demand, requirements for connecting new cloud regions, maybe reacting to a spurt or a resilience issue in a much more profound way than we have done up till recently. As great examples of these, I encourage you to use your favorite search engine and explore the Curie cable that's going from Chile up the west coast into the US, or the Dunant cable that's going across the Atlantic. Actually, Dave, my colleague, is going to talk a little bit more about some of the exciting technology firsts that we've got on the Dunant cable in his next session, next up. So the great news, though, for cloud customers is that you can connect to this network at 134 locations around the world. And it can be directly or through a large number of cloud interconnect partners. Right? It has never been easier than it is right now to get on board our global network and share in this underlying fundamental performance. So, traffic grows, networks change. We build new cloud regions. We go to new locations. Cables come out of service, new cables come into service. It's a dynamic system, and as we've evolved our network, we've also evolved how we plan to build our network. We've gone beyond looking at historical data on failures or outages, using some Monte Carlo simulations, and then forecasting a probable underlying topology resilience. What we're moving towards is a form of simulation based on discrete event modeling. So we type out a number of specific events, from a card failure, a submarine cut, a service error of various types. We assign them each a probability curve or a frequency distribution, an impact, a blast radius, and any interdependencies. We then use all these discrete events to simulate forward an equivalent of decades of runtime on the network, and we do this against a number of future topologies. And what we're finding this gives us is a much better understanding of the impact on our network SLO that changes in the network, new acquisitions, new capacity, new routes will actually have. Sounds like a lot of effort. Is it worth it? Fair question. I can tell you the answer is absolutely yes, and here's why. Last year, it's a real but slightly obfuscated example. These are 4 cable paths going between 2 of our data centers in the APAC region. What you're seeing with the black lines are outages on those submarine cable paths. Okay, and because they're submarine paths, they can take weeks or even months to rectify. You have to get ships on station. There may be permitting issues. There could be weather issues. What's also particularly interesting is those red circles, those red ovals, sorry. They indicate what we call a dual case failure. So a dual case failure is when we have 2 of these paths go down at the same problem. The reality of life is that networking doesn't stop at the edge of our network. Okay? All of us, the vast majority of us, need to reach people over the public internet. So what are we doing to bring this ethos and fanaticism on resilience and performance beyond the edge of our network? I mean, it's not a controlled space. Some of you may well have heard of route hijacks that have gone on in recent years, and we've been impacted by them. And the reality is that is a tough problem to solve. A small African ISP, keyboard error configuring some things, can propagate and actually cause issues on a global scale. We need to try and get better at this. We need a better internet for cloud. So we're doing some things. But let's consider this example. We've got a bad actor ISP. Let's assume not malicious intent. Let's just assume keyboard slip. They start advertising some Google IP space out. They also start advertising some IP space from another one of our peers. So this isn't great. It's a route hijack situation. These routes are going to start to propagate throughout the internet. User traffic is going to potentially start to go to the wrong location. Okay? We're tackling this in a couple of ways. First thing we're doing is making our own systems better and better. So our monitoring and filtering at the edge, we're improving to be able to detect and respond and mitigate to these sorts of issues as quickly as possible. And that's great. So you say, well, there's only so much that Google can do ourselves. What are we doing to make the internet better? Well, we're working on two aspects of this. We're working with other organizations in the internet community. The first thing we're doing is we've joined MANNERS. MANNERS is a fabulous acronym. It stands for the Mutually Agreed Norms for Routing Security. It's sponsored by the Internet Society, and it's people coming together to try and make routing more stable and more secure across the internet. I'm happy to say that Google will shortly start applying route filters based on IRR entries to all of our public BGP sessions. So we're going to use IRRDB, and we are going to be applying some encouragement to all of the networks out there, networks we connect with, to tidy up their IRR entries and to start to spread this level of resilience in terms of route origination checking and validation across the internet. That is going to take a little time, though, right? It hopefully won't take as long as IPv6, but it will take some time to propagate. So what we're also doing in the short term is implementing peer lock. Peer lock is where we actually work with 15 to 20 of our very biggest peers, and we agree with each other not just where we're going, not just which routes we're going to accept, but from whom and over what valid paths. So a combination of these things, a combination of MANNERS and peer lock, we think should be able to dramatically stop the impact of some of these things. What does that mean? Well, we think it's going to really minimize the downside of route hijacks, and it's going to make, ultimately, the internet more stable and more functional and a better place for our cloud customers to be working with their customers or their users. That's on the physical side now. I'm going to turn you over to my colleague Dave, who's going to talk about some innovation a little bit higher up the stack.
Thank you very much, Donald. Hi, everybody. My name is Dave Phillips, a colleague of Donald's. And I'd like to talk to you today about the performance and innovation we've got going on at Google, really at every layer. A message I want you to take away is that there's all these engineers at Google really obsessively working at making every aspect of performance faster, and also really working at how we make that performance very faster and very accessible and usable for you folks, our cloud customers. So I'll talk about performance at 3 layers. I'll talk about network software, the fundamental algorithms we use inside and we use out on the internet. Donald talked about trying to make the internet better and faster for everybody, so I'll talk about some of the efforts we have going on there. I'll also talk a little bit about the physical layer and how you can tap into that and gain some advantage from that reach and that scope that Donald talked about. And thirdly, then, I'll talk about the Andromeda cloud layer, this virtualization layer where all of your services live and all of the performance improvements and innovation we've got going on there. So some numbers, I mean, in terms of infrastructure, we spent about $30 billion in the last 3 years on infrastructure. That's 30 and billion with a B. This year, we're going to spend 13 billion, somewhere around. So this is the idea of some of the scale of investment we have into this infrastructure and into this innovation. Talking about innovations, here's a snapshot of many of the innovations we've gone public with. In order to deliver things at the scale we need to deliver at to give the Google services globally, we've needed to solve a lot of problems ourselves. An important takeaway is that these innovations and this fundamental infrastructure, these are fundamental building blocks of how we build the cloud product. So what you can see from here, I mean, let's take Maglev, our software-defined load balancer. That's been in use at Google for the last 10 years, taking in all of that front-end traffic. And in fact, this is a fundamental building block infrastructure of how we do some aspects of cloud load balancing. We have 4 pillars of our SDN. We have B4, which is a very large interconnect SDN environment. Jupyter, which is a fabrics within our data center. They're able to aggregate those tens of thousands, hundreds of thousands of machines together to give you that very high levels of performance. Andromeda, which we'll talk about, this software-defined virtualization layer. And Espresso, as Donald talked about, taking that SDN strategy all the way to the edge. As you can tell, we really like SDN. It's the only thing that's able to give us the level of scale and performance we've needed to be able to overcome the scaling challenges and the performance targets we've needed to hit. And you know, much more to come. So for example, MagLab's been in place for 10 years, but the paper was released about 4 years ago. So you can imagine there's a lot of stuff here that in future conferences, you'll see this filled out retroactively. Okay, let's talk firstly about performance at the network software layer. So let's talk about the fundamental algorithms we use to exchange and communicate traffic and how we're looking at rethinking them to make them faster, to make them better, and very importantly, make them so that they're very easy for you to use. So I want to talk about 2 things. I'll talk about BBR and I'll talk about QUIC. So first up is BBR. BBR stands for bottleneck bandwidth and round-trip propagation time. So TCP, the fundamental congestion control mechanism of the internet, for the longest time has been loss-based, right? Since the late 1980s. And actually, this has worked great for a long time. But in fact, when you start talking about modern networks, which have very high-speed links and potentially, in some cases, smaller buffers, actually, counterintuitively, it doesn't necessarily work so well. TCP being loss-based, once it hits some loss, it will back off very, very sharply. So in order to get really good performance over modern networks, we looked at rethinking that fundamentally from the ground up. That's the BBR algorithm. And what that does is it's fundamentally congestion-based rather than loss-based. What it's able to do is model and understand the actual throughput you can get end to end and then try and get to that maximum point. We've seen very significant improvements when we've enabled this. On YouTube, we got up to 4% greater throughput worldwide on average, up to 14% in some countries. These are very big numbers because that was very highly optimized to begin with. Now, for you, how do you use BBR? Well, in fact, once you come into our network and once you speak from your front ends to your back ends, you're using this, right? And getting that very fast performance. So for example, if you go from a front end to a Google Cloud Storage, you're using this. And if you're using Google Properties, or you're getting to a point where you're terminating on the network, you're using this automatically. Okay, let's switch tracks. Let's talk about QUIC. Again, another innovation in the fundamental software level of how we interact, how we communicate, how we send traffic. So QUIC stands for Quick UDP Internet Connections. It's been in use at Google for maybe 5 or 6 years at this point. So what QUIC is, well, a very common transaction you want to do is HTTPS over TCP and TLS for security. When you do that in that way, it's a full 3 round trips before you can actually start communicating. What QUIC is able to do is get you communicating after just 1 handshake or 1 round trip, and if you've communicated with that server before, you can start immediately communicating there. When we've pushed this out, we've seen up to an 8% performance increase. And again, that's a very big number because a lot of these infrastructure is very highly optimized already. In order for you to be able to enable QUIC, simply on your console, under the load balancers, you can actually enable QUIC right there, and you're getting that speed and that access. QUIC is also extremely good for multiplexing for many streams. Traditionally over TCP, if you're multiplexing streams and you lose some traffic, all streams are held up. Whereas with QUIC, not the case. Just the stream that's affected is lost. The other streams are good. Also, QUIC has a connection identifier instead of a tuple. So if you're moving between networks, as you probably are here, between wireless networks and Wi-Fi and wireless, you're able to maintain that QUIC connection. Okay, so there's some examples of fundamental software-level algorithm improvements geared towards making things better. and very easy for you to use them and access them. Let's jump on now, switch tracks, and talk about performance at the physical layer and why that matters to you. This graphic you might recognize. This is from, we had a lot of press last week about the Dunant cable. This is a transatlantic cable going from Virginia to France, named after the first Nobel Prize winner, Dunant. Now, very good write-up in Wired about this. Thinking about this, so first of all, private cable, our second private cable, one of 13 subsea investments we have. First of all, having that level of investment gives you that deterministic capacity. When you need to grow, we're going to have that raw capacity. Also, very significant innovation at this layer too. So when you're in a data center, in an interconnect PUP, and you're looking at trays of fibers or ducts of fibers or trenches, you're typically seeing hundreds of fibers or thousands of fibers. But actually, when you talk about subsea cables, the sheer amount of power you need to regenerate those signals means that most subsea cables have 6 or 8 pairs max, okay? All the way across the Atlantic or the Pacific. This system here has 12. Uses a new technology called space division multiplexing. Enables us to regenerate multiple fiber pair signals with one repeater. So able to get more fibers on that. So significant innovation at this level. Now, why does the network matter? Or why does having all this reach of fiber and all this reach of cable matter? Donald gave a great statistic there, about 99% of our traffic being directly handed off. We talked about all those 134 interconnect points, and we showed you the sheer reach of the network. Well, a good way to look at this is the differentiation between our premium and standard tier networking. If you're a routing person, this is the difference between cold potato and hot potato routing. I'm from Ireland. I had to learn to say routing instead of routing, so hopefully I keep remembering that for my audience here. Okay, so with our standard tier, this is generally how clouds work, which is that you get close to where your compute is, you then ingress on the service provider network there, you get to your compute, and then you get kicked out as soon as possible back onto the overall internet, and you take your chances on the wider internet. With Google Premium tier, you're going to ingress at the closest point to the user. You're going to come all the way across that very, very fast, very high performance Google backbone network to where your compute is or where you need to get to. You're then going to go all the way back over this very high performance Google network out to the customer, right? So you're going to spend the maximum amount of time on the Google network getting that VIP treatment all the way. And as we said, so 99% direct handoff, so incredibly well-connected network. What does that mean in reality for you? Well, this is some third-party analysis of the performance between tiers. Note that the graph doesn't start at 0. The first number there is 3. So what you would expect is a very significant performance improvement if you're coming across this very high-quality Google backbone rather than taking your chances on the internet. About a 1.8, 1.9x throughput improvement. You can check out those reports yourself. I just pulled those numbers from last month. Right. Now, let's try and put some of that together and show you how you can use that in your solutions. And enabling premium tier, very easy. On your VPC configuration, you're just going to click premium tier, very easy in the console. I know when I said hot potato, cold potato routing, a lot of people had flashbacks to their CCIE and how they had to do all the config. You don't have to do any of that. You just enable it in the console. We've made it very easy. Okay, let's put some products together and show you how you can use the reach and power of this Google network. So this is global load balancing. So let me put together 3 products here. Global load balancing, your VPC, which is your virtual private cloud. I'll talk a little bit more about that, but that's the base instant network that you build, and this premium tier. Well, when we do global load balancing, what we do is we give you a virtual IP for your solution. Then the external IP we map that to, what we'll do is we'll actually anycast advertise that out all of our edges, right? Now, what that means is in this case, we have Maya in California, Bob in London, and Shen in Singapore. And because that one IP is anycasted out everywhere, all of those folks are going into the most proximate location to give them that very good performance. You don't have to go playing around with DNS or any of that. And because it's one overall system, we're able to recognize if there's a problem or an overload in a particular area with your servers and able to redirect you to one of the other sites, right? So using that, you then have the power, easy access to this great big infrastructure. Now let's kind of rewind the clock back a little bit from that scenario. I don't have an animation, but let's just imagine. Let's just imagine right now you start off with, you just have some servers, some VMs on the West Coast in the US West 1 area. So, well, what that means is that anybody wanting to be served in your app is going to go to the US West 1 region, okay? Let's enable premium tier. What that means is Bob in London is going to be pulled into the Google network in London, pulled all the way across our premium backbone to be served in your servers on the West Coast, all the way back across our premium backbone and handed back out in London. Same with Shan in Singapore. Now let's take that a step further. You say, okay, well, I'm getting pretty good performance for Bob, but I want to get better performance again. I'll put an instance in London or in Western Europe. You put that instance in Western Europe. Now, because you've already got the global load balancing, because you've already got the VPC is inherently a global construct, seamlessly, your traffic is going to be pulled in and served in London. Same then as you expand to Singapore. So very easy for you to take advantage of this very significant high-performance infrastructure, putting these products together. I think that's a key message. There's a lot of underlying complexity, but very easy for you to take advantage of all of this performance. Okay, we talked about software algorithms. We talked about the physical layer. Let's talk a little bit about the Andromeda layer. So Andromeda, this is the software-defined network virtualization layer that lives on top of this infrastructure, and that's where you're configuring all of your cloud solution. So the fundamental building block of Andromeda on the network layer that you're going to put together is this idea of a VPC, a virtual private cloud. And this is your private little slice of Google dedicated to you. Key point is that VPCs are inherently a global construct, right? Like in other cases, they can be a regional construct, but other providers need to replicate them in different regions. In our case, it's one global construct. Now, if you're in the financial services or the medical industry, you may need to contain your traffic. That's okay, we can do that too, but inherently it's a global construct. One model, very easy model to use globally. Your traffic then, once it's in your VPC, is not touching the wider internet. It's going across our network. And very easy for you then to use this one model to manage and maintain everything. We have also this concept of a shared global VPC, where you could have one overall shared VPC and then projects underneath that, host projects underneath that connecting into it. So one overall model for you to use. This is then ultimately what Andromeda does, is it gives you that functional and performance isolation and separation. So you all can have your private slice of Google, the green customer, the yellow customer, and the red customer, all having full performance and functional isolation while taking advantage of that very, very significant underlying network and underlying infrastructure. And you see how you can layer all the load balancers and so forth on top of that. Okay, breaking down into Andromeda itself. A key message here is that we take an awful lot of the networking functions and push them all the way down to the host layer. In fact, we do this in the user space. And why do we do this? Why do we do this in the user space software? Well, firstly, we're able to get really, really good performance. We're able to go up to plus 3 million packets per second on a single core because it's not in root, it's in user space. You know, there's no root access, there's no kernel issue. You can bring back user processes very easy, very quickly. We can also iterate very quickly. We can push releases. It's a very a small footprint for security. We can do continuous fuzzing. We can do live migrations. And all these bring a very direct benefit to you. Use something called FastPath for direct data transmission. We have coprocessors for more complex stuff that we need to do on there. Gives us very, very high performance. The data plane then of all of this is fully programmable. This gives you an overall snapshot of the Andromeda architecture. And, well, as you would expect, it's fully replicated, it's fully sharded, fully duplicated across regions, across zones. Looking at it, well, it's a hierarchy. We have a cloud cluster manager, performs many of the overall configuration tasks. Below that's our fabric manager layer, and below that then is our OpenFlow layer. We push the programming down too. And the key message of this is because we push an awful lot of the programming and an awful lot of the networking into the hosts and into the fabric stack itself, is that we get very good horizontal scaling performance. So let's take, for example, our internal load balancer. Now, the sort of kind of secret of the internal load balancer is there isn't actually an internal load balancer. It's all distributed within the fabric. So normally when you do this kind of load balancing, you have a box or you have a VM, and that can be a choke point or that can be a failure point. Because of the way we distribute this out to the fabric, firstly, you have huge horizontal scaling, but secondly, you don't have a single choke point. You don't have a failure point like that. And that gives you some idea of why we went down this direction and the kind of performance that we can have. So key takeaway, Andromeda, a very high performant OS bypass, user space process running on dedicated core. Let's look at some of the efficiency evolution we've gotten over the years. Again, we're very obsessed with getting better and better performance, right? And you can see that we look at every aspect of performance, try and make it better. And people constantly working on that at Google. So we knew that cycles per byte was a key metric we would have to get down and get better at. And you can see somewhere in the order of a 16x improvement since we started. The big jump there, Andromeda 2.0, moving everything into the host space. Andromeda 2.1, we still had just down to one thread handoff. Andromeda 2.2, no thread handoffs and in-memory copying. Let's see, some of the improvements since we talked to you last at Next, and continuous improvements every week, but some of the big ones. So LPM, longest prefix match caching on the machines. Very good for internet-facing heavy workloads. Our Hermes system for provisioning and pushing config to new VMs, 2x improvement, down to 15 seconds of initial configuration. It's about 30 years ago. Hoverboard, which is an internal thing for scaling routing, we're applying that to our load balancers. Gives us very significant scale-out advantages. We've done a lot of improvements around isolation. And last year, 2018, there was a lot of these big CPU issues. Spectre, Meltdown. And because we had this stuff in the user space, we were able to mitigate against this in such a way that really probably the first communication you had was that you were patched already. So these are some of the big things that happened in the last year. So continuous body of improvements and always ongoing. Leading us up to what are those improvements? Well, ultimately means better, faster products for you. So at Next, we're announcing up to 32 gigs on your VMs. So limit before this was 16. And hopefully I've also shown you with this network, you're going to be able to get that speed, right? What you're going to need a Skylake machine up to 16 vCPUs, but that's available in all regions. So please talk to your account rep. Also, in alpha, up to 100 gig per second on your GPU machines. There's the spec there. It's a controlled alpha. You're up to 96 vCPUs and 8 GPUs. You can sign up for that alpha to give you that 100 gig performance. So take away from here, we're working all the time at every level of the stack to give you better and better performance. Now, how do we measure and monitor that performance? Key point. My colleague Lakshmi will tell you all about that.
Thank you, Dave. So one interesting point about this conversation or this presentation is that we are talking about what Google has done over years in infrastructure, in continuous improvement and performance and resilience and everything. And then we also give you like a peek into what we have built so far and what we are planning to build. So all those three aspects we continue to cover. So the reason that we go back to like what we are doing in infrastructure is to show that this is all we can offer to all the cloud customers. We are continuously planning and working towards giving that scale of information visibility, that scale of performance to all the cloud customers that Google does it for its own infrastructure. So some of these announcements here, and before I start with my, my part about monitoring and visibility, there are some other announcements that happened yesterday, and there were blogs written, which is, again, around high throughput, high performance, and reliability. So we announced HAVPN with 4 nines availability for VPN. We did 100 gig availability on interconnect. So if there are any of these high performance and reliability things that matter to your network and to your applications, please do try those as well. So comprehensive monitoring. So I'm going to touch upon, like as I said, like things that we do today in the infrastructure, all the way from like hardware, platform, software, and also towards the client side. So I'll go into like each of the layers and how we monitor and how do we bring host level, network level monitoring, inter-region, inter-zone, intra-zone, all of it, and taking it all the way to the end user experience, and how we work with the providers that you heard, like ISPs, network providers, throughout the globe in order to get you the monitoring experience and to our own selves, like to the SRE teams, to the support teams. So all of that global monitoring at each of the regional global level, how do we put that together, take the information from the host, take the information from the network, put it all together and offer it to you, and offer it to you as a cloud customer, and offer it to ourselves to monitor our own services and applications. So every machine, every component in Google's infrastructure is part of our gigantic network monitoring infrastructure. So we start from, let's start from host. So at the host level, we continue to monitor the host for bandwidth, for latency, RTTs all the time. And none of that impacts any of the application performances that you hear today. When we talk about 100 gig GPUs, when we talk 100 gig bandwidth with GPUs, when we talk about 32 gig, when we talk about 100 gig interconnect, all of that happens with all these host level monitoring in place and with our own services running on that infrastructure. So that's where we start from. Then we go out of the host, then you go to the network, we run continuous probes in our systems, different kinds of probes, black box, white, passive monitoring, active monitoring, all kinds of monitoring that you're aware of. We continuously run in the infrastructure. We combine the value of this probing, which gives you information like packet drops, latency. We combine that with the host level information, put that all together to make the optimal use of our host and the network. And what does that mean? When I say optimal use of the host, so when we talk about 32 gig, we used to give 16 gig per VM. VM egress was 16 gig. We bring 32 gig to you. We are talking about innovation at per vCPU throughput we are talking about. So we give like 2 gig per vCPU. That's so much. You can go and compare with what other platforms and what other machines give you. 32 gig, no, you don't have to do any configuration change, no API change, no, you just start to get 32 gig. And we continuously keep monitoring that we are able to give you as a cloud customer that throughput. Then we go from 10 gig connectivity to 100 gig connectivity on interconnect. We continue to monitor at the same scale to all the customers, and same statistics, same information, and we are optimizing that all the time. So that's what we continuously do with our probers, with our host level information. We monitor that, optimize it, and continuously keep providing to ourselves as well as to our customers. So in addition to the host level, network level, probe level, VM level, CPU level, all that monitoring I talked about, so we also work with, we also go outside. Let's talk about end user experience. I'm saying end user, literally somebody who has a device, handheld device, and how we improve their experience. So we have built external connectivity information, some tools where we can go, some work happening even in open source community, where we go and collect information from all those devices running around the globe, accessing all global applications that Google has, its own services. We continuously collect that data, working with a lot of our partners throughout the globe. We continuously look at like latency information, packet drop information, the device reachability information. We build that database in our, we build that database for all that connectivity information for end users and continuously optimize it for region, reach, location, all of it. So you heard about the global load balancer, Anycast load balancer that Dave talked about. So in order, that's optimized to give you the closest and the fastest reach from an end user's perspective. So we collect data from different services which are running on cloud. We collect data from end user perspective, from for our end users who are using Google services. We combine all that data to give you the best and the fastest experience as an end user of our services, as well as of your own services which are running in cloud. So, and what do we do with all these metrics? We're talking about generating so much of monitoring data, so much of data at different levels. Of course, we use it for alerting and monitoring, like a lot of NetOps and SecOps teams do. So we continuously monitor and look at the alerts. A lot of the data that we use, that is being used by SRE teams as well. It's when I'm talking about alerts and monitors and being reviewed and being looked at, I'm talking about all these being automated, right? So we are talking about a company that has invested hugely into software, hugely into automation. So all these alerts being automated and being continuously looked at. A lot of this work has already happened, and we continue to improve upon that. So we look at this data, and as I said, because it's all software driven, we use that data to feed back into our application. We feed back into how do we allow our users to reach fastest to us with least packet drop with the lowest latency. So the 4 parameters of networking that we continuously look at and continuously improve on: bandwidth, latency, jitter, and PPS. So how do we continuously give you the high end of bandwidth PPS, the low end of jitter, and low end of latency while we reduce your packet losses all the time? So in case of when we manage our infrastructure, then we do not have to provide you that visibility. But when you as a customer, you as a cloud customers would like to get access to this information, then we are building on tools, we are building on products where we would be able to offer you all that visibility, because you would like to understand where is my packet drop happening, what is my latency happening. You would not just like Google's infrastructure team to be automating it. So that's how we continue to do automation for our own infrastructure, but we understand there are some metrics, there are some parameters that you would like to continue to have visibility into and access into so that you can automate it for yourself. So advancing state in the, from a device. So we talked about host, CPU, interface, network, all the way to the end users. So, but then we do build a lot of our hardware, a lot of all the software. We also work with partners. We also work with devices like in routing, switching. So we use the best of the technology wherever possible. We do partner with hardware vendors, switching vendors, and we deploy them in our network. So when we are using a third-party devices in our network, then we do need to understand, we do need to work across all of them, those vendors, to get a standardized telemetry information. So instead of, the standards that used to exist earlier, they were like standards like syslogs, SNMP, NetFlows. Those were the standards that existed in order to kind of collect the data information from those devices. And then there would be a polling interval. So most of them were like polling at 5 minutes, 1 minute. So that's how we were used to when it comes to devices. But for a scale that we are running at, and when you're talking about cloud application, you're talking about a VM that may just come for like a minute or 2 minutes. So then polling intervals like 5 minutes or even 1 minute may not really work. So we worked with all these vendors to put in streaming telemetry, where instead of just pulling at a specific interval, we are able to just, those devices are able to push that information in a streaming manner so that we can run that at the same frequency and the same time interval that our applications require. So we work continuously, even with those vendors, to standardize across the protocols and to standardize across different kinds of interfaces in how we can pull this information. So like pull versus push model, we continuously work with all of them so that we optimize their infrastructure, and that knowledge that we work with them gets used across any other vendors or any other partners who are trying to utilize that information. So you heard about this reach that we have around the globe. So that's a lot of the, we do run our own WAN, we have our own presence, but we cannot run a global infrastructure if we do not partner with a lot of peering points, peering partners that are there. So we do maintain a global footprint, and we have a pretty open peering policy with a lot of ISPs out there. So when you want to maintain those peering policies and peering partnerships, we also have an ISP portal, and you see a snapshot of it here, where we can we at least offer 3 things to our network edge partners. So we give them like a view into what is the traffic that is coming to them from Google, why. So the reasons behind, like, what are the policies, why means what are the policies. Then we also give data around traffic loss, PPS, and all of that, so that we can continuously optimize the service delivery between our partners and us. And we also give our information so that we can continuously capacity plan. Like when we are growing at such a enormous speed for each of the ISPs, so we need to be able to explain to them that what is the capacity that we need from them, and we continuously work towards that. So our ISP portal helps give them that view, and which is a common view between two organizations. So all of this I talked about, which was infrastructure investment, hardware, software, working with partners in the monitoring and telemetry space. And then what are the products that we have built based on that information, as well as the innovations, additional innovations that has happened. So there are some of the examples here. Load balancer telemetry. So we do give you capability to troubleshoot the load balancer. So like as Dave mentioned, it is really a software we are talking about. So how do you troubleshoot that software? So we do give you access to information like what are the number of requests that you have, what is the latency at the load balancer front end and the back end, the bandwidth that you have. We also give you insight into VPC flow logs, so you can generate flow level information. And even with that, you get a lot of metadata around it. You will get information around bandwidth and latency even through your flow logs. Then you also have firewall logs, where you can get a per rule level information for all your firewalls that are out there. Sometimes this kind of information may sound massive, but we do have like additional enhancements in the product where you can decide that, oh, I only want subnet level information for my firewall logs, VPC logs, and I just want the specific rules to be logged. So you can use all those combinations, but we do want to make sure that we give you enough information when it comes to auditing and monitoring your infrastructure. So with all that standard logs and information that we generate, we partner with various partners. There was a session yesterday on network performance monitoring where we did bring one of the partners on stage, like Cantic. If you have not attended that session, I would encourage that please go ahead and then look at the recording later. So with that, I will just summarize this entire session into what you heard so far is that how do we operate our infrastructure, both for our own services as well as for Google Cloud at scale, and how do we make it resilient? What are the products that we have launched so far and we have launched during Next? Then the innovation that we have in the performance space, all the way to like VM throughput, to interconnect, to high availability of VPNs, and then extensive telemetry and monitoring tools that we offered. So with that, these are a few other sessions that we had during Next. So please take a look at that. As I said, we also had a blog release yesterday which talks about a lot of products, other products in the high availability and the throughput and performance space that we have launched. So please take a look at them and use them. If you're already using them, then it's perfect. Otherwise, please try to take a look at those all those launches that we have done. And with that, I will invite my colleagues on stage. So if you have any questions, we are open to questions now.
So we just told we are out of time in the session, so we're going to not do formal Q&A, but we will be hanging around here at the front. There's a Dory question as well we'll get to, so if you have questions for us, please come to the front and then join us as we sort of drift outside. We're very, very happy to talk to you all. Thank you so much for a 9 a.m. last day session at Google Cloud Next.
Thank you.
Thank you for coming. This concludes our session. Please exit the forum to your right as quickly
Hi there, and welcome back to the Next Live show. I'm Reda Meyer.
And I'm Stephanie Wong. It's our last day together here at Google Cloud Next 19. These past 2 days have been a whirlwind of product announcements, demos, experiments, and inspirational stories from people who are dedicated to making the cloud better for everyone.
And to help with that mission, we've made all that content easily accessible to you at g.co/nextonair. There you'll find videos of everything we've live streamed and recorded at Next, including the keynotes, all the breakout sessions and fireside chats, and all the Next Live show demos, special interviews with Google Cloud leaders, and more. It's all on demand for you to watch and share.
You still have time to check out the other 5 channels of Next Live programming organized by themes: build, run, analyze and learn, secure, and collaborate.
We're joined now by Adam Seligman, Vice President of Developer Relations. Now, I love the theme of last night's keynote, get to the fun part. Can you talk a little bit about how you chose that theme and why you feel it resonates with our developers and really all technical practitioners?
Yeah, you bet. Thanks for having me. It's exciting to be here. Keynote was super fun, and the whole idea was to really celebrate what developers and operators actually do every day. You know, hopefully they're spending hours a day productively building apps, running apps, deploying apps, monitoring apps, and not dealing with all the other stuff, you know, that you normally have to do when you build applications, especially in the enterprise. Getting out of waterfall and getting to agile, not just throwing over an app over the wall for someone else to operate, but taking ownership in a DevOps culture and operating, and really removing all the barriers. Everything from not having to manage and shard databases, not have to manually manage your VMs or even pick VM sizes, and really just get to the heart of building applications and then let the cloud take care of it from there. That was the spirit we wanted to capture in the keynote.
So configuring networks, rewriting apps due to cloud provider changes, and waiting around for build, test, and deploy are clearly not the fun parts. Didn't Google once face these sort of issues, and how were we able to remedy that at such scale?
Google has built a lot of great software to run these services that billions of people use every day. So a couple of decades of experience went into how do we help Google developers become incredibly productive so they can spend an hour, 6 hours on average of writing software every day and absolutely minimize everything else in the chain of getting to deployment and getting that service out to production where a small number of users can test it as a canary deployment and start giving you feedback. So we're trying to build that into our cloud. We've seen the rise of DevOps practices out in the industry, but now we're building into our products with products like Cloud Code, like Managed Kubernetes and CSP, Cloud Run, our new serverless offering, just really reducing the barriers that anyone, like a Google engineer, can build code and get it into production as easily as possible.
Yeah, fantastic. Now, if you had to pick just one best practice from yesterday's keynote that you want developers to walk away with, what would it be?
I'm going to cheat a little, and instead of a thing Google said, I really liked what Twinkle Desai said, who is a VP at Kohl's, who started her career as a developer and a Unix sysadmin, and she built a lot of automation at Kohl's. Now she runs, a couple years later, she runs a 200-person team. They have 100 microservices, 5,000 containers. It's all automated. It's running on managed GKE on-prem. She said they've been through 2 big holiday shopping windows, which in retail is a really big deal. So I'm thrilled that Google Cloud can support retail customers. But by making her people super productive, it's been really great for Kohl's and really great for her career.
Now that's an inspirational customer story. We also saw incredible demos during the keynote yesterday. Can you tell us about some of them and which one was your favorite?
There was a couple that were a lot of fun. I really like what Wix is doing with Google Cloud. They've gone from being like a drag and drop web environment, but now it's totally programmable and extensible with Google Cloud. That's really exciting. The opening demo that Mandy Waite led us through, like her dev team is taking us through, was very, very cool because it was a mix of developers doing VM-based development with Jenkins for deployment of new VM images, a container-based app in the middle, and then extending with new services with functions, serverless functions, which is pretty cool. So to see all those teams kind of working together and using tools like Cloud Code, our new IDE integration for VS Code and IntelliJ, it's just awesome. People can work the way they want to work. It all works together, all runs on Google Cloud seamlessly. One pane of glass with Stackdriver to observe and manage it. And I think that's great. Let developers do what they want and get to the fun parts.
That's fantastic. Thank you so much again for joining us today and giving us some of that great information.
And let's check in with Joanna for a closer look at the network postcard experiment and to understand why speed matters.
Hi, I'm in the dev zone once again, but now I'm with Terrence Ryan, who's one of my favorite coworkers. I'm not gonna lie about that. But so this demo in particular, it's a digital postcard, is that right?
Yeah, that's kind of the idea. The idea is you take a selfie or picture, and we will bounce it around our network, our private network, all around the world, and print it out for you. So the pictures that you get over here are pictures that have traveled around the world digitally.
Oh my gosh, and so that's what these stamps are, each data center?
Each data center, we have a stamp for it, and it doesn't stamp it until it's in that data center.
Now, when you talk about a private network, you mean the actual physical cables and data centers that Google built around the world, right?
Yeah, exactly. The same data centers and same infrastructure that powers search and mail. Also, under the covers, it's available to Google Cloud customers as their private network. So whenever you talk between one machine and another machine on Google Cloud, it's always traveling on our network. It never leaves the network. And so you get much better performance in terms of being able to communicate and security because it's not leaving, it's not on the public internet.
Oh my gosh, this is actually one of my favorite facts about Google Cloud. It's a fun fact, which is we built an infrastructure to power our search, and then we started opening that up to other people so that you don't have to reinvent the wheel. But it's really important that we make it easy to use. Was this pretty easy to set up?
Absolutely. Like one of the great things about Google Cloud's default networking in our projects is if all the machines are in the same project, all the VMs are ordered powering the relaying and the stamping here. If they're all in the same project, then they are automatically wired to talk to one another without a developer having to do any work to make that happen. And so what that allows you to do is kind of get started without having to set up like VPNs and VPCs to get all that working. All of that is done for you. All the routing is done for you. And if you want, this is an open source project, so you can actually pull down and see how we set it up and see that like it really is that super simple.
And I like that it makes it accessible to someone who might not have that networking experience or background, but so long as they can understand the theory, they can actually get going.
Yep, exactly.
This is so exciting. I love this demo. I am so happy to take home my photos. And more importantly, the fact that it is open source means that anyone at home can play along, even if you don't get to have your own cute photo to take home. And I hope you'll have a great time, and thanks for joining me in the Dev Zone.
Great job, team. The next session is about to begin, so we'll see you right back here in less than an hour for a deep dive discussion on APIs with Amit Zavery, VP of Engineering at Apigee. Then we'll head back to our showcase for more demos. Stick around, you're watching the next live show from San Francisco.
Please welcome Head of Product Management Cloud IoT, Anthony Passamard.
Thank you, and thanks for being here. It's tough on the third day, early morning. Who went to the concert yesterday? No? Oh yeah, double kudos for you coming here this morning. So thanks for being here. Welcome to that session on how to accelerate your digital transformation through IoT, data analytics, and AI. My name is Anthony Passamard. I lead the product management team for Cloud IoT at Google. I'm really happy to be here today. I have a few customers who will join me on stage during the session. I have also a great partner, Hitachi, is going to come on stage and talk about their experience. Let's go and get started. If you're here today, it's probably because IoT, you know that IoT already is producing value. It may already be, or you know it can produce value for your business. Either it's part of a small implementation that you're doing, some use case, or it's part of a broader digital transformation initiative inside your company. You know IoT is producing value and that you want to learn more about that. We've seen that across different industries. For example, in agriculture, how to reduce water usage, increase yield. In oil and gas, it's more about predictive maintenance and increasing security of workers in those oil platforms. We see it in logistics for asset tracking. We'll talk a little bit about an example there. I mean, it's really across every industry. Those are just 3 industries that I want to point out, but it's really across all those industries that we're seeing IoT having an impact today. And that impact is pretty undeniable. The driver behind those use cases are oftentimes seen through 3 mega trends. Those mega trends are smart factories. That's a very important one happening right now, the rapid urbanization and the digitization of workflows. In smart factories, you may hear manufacturing 4.0, you may hear IoT, however you call it. The manufacturing process is really changing right now. It's adding a lot more real-time insights, a lot more just-in-time provisioning of the assets, of the raw material, of the parts, just-in-time deliveries. You have now robots inside the factories, either moving around or stationary doing their work. All this is driven by machine learning and AI. The addition of machine learning and AI in factories has really transformed how things are built today. And that's a big transformation and a big shift that's driving almost everything in the value chain. In urbanization, there's a pretty staggering statistics by the UN that in 2050, 64% of the developing world and 86% of the developed world will be urbanized. That means that shift from the rural areas to the urban areas is pretty massive and happening at a rapid pace. So cities have to get data from sensors, either traffic light, traffic, buses, transportation, waste management, energy consumption for the city. All of those have to be equipped with IoT so the cities can plan better for that growth and can serve their residents better and increase security also, which is a big challenge for those rapid urbanizations. That's a big, big trend that's happening. The last one is almost across every industry. It's about the digitization of workflow. It's replacing things that were done manually or were really difficult or discrete to happen through an automation workflow, using machine learning, using AI to really accelerate that. So it's about decreasing production costs. It's about faster turnaround time. It's about increasing efficiency. That digitization of workflow can look like, I'm replacing clicks from a call center agent by a script that just goes through that whole process, gets data in SAP, and brings it into the case. Could be that simple, but it's really happening everywhere, and that's really accelerating everything that's happening today. The real-time nature of the digitalization of workflow is really important there. Real-time is something I'll come back a lot during the session because we're seeing that with real-time data, you can really realize and maximize the value from your IoT implementation. This is a statistics from IDC. By 2025, which is not too far from now, but a quarter of all data generated in the data sphere will be real-time in nature. And what's even more staggering is that 95% of that quarter of data is driven by IoT. So IoT is real-time. That's really what's driving all the real-time data in the world. So that's a pretty impressive statistic. So real-time is an important concept. And it's not a surprise to see that after a few years, I've been in that space for quite some time now, and I've seen kind of the hype and the disillusion curve a little bit, and now it's coming back. But it's not a surprise to see that that's a study from IoT Analytics, that 50% of the companies in the next 2 years are going to start to see value from IoT, and that's from 12% in 2018. That's different from the stats you've seen before, which were around how people will do an IoT project or will start an IoT project. We've seen a lot of those stats. This is about generating value from IoT projects. That's a shift. That's really going from a POC to production, and that's really starting to get the reality of what IoT should be doing, which is producing value. We see that real-time insights and that real-time value in different areas, obviously reducing costs, driving efficiency. We've talked about that. But in logistics, for example, we had a customer who's transporting biopsies from healthcare, from a hospital to a lab. Having visibility of that biopsy, having the visibility of the temperature of that biopsy throughout the whole route that sample is taking is extremely important. If the biopsy has a bad temperature or goes bad during the transport, it's useless, and it may be a little bit of a problem for the patient, obviously. So that real-time nature of data is really important. You can't have that the next day. You can't see the next day that, that track was not good. In manufacturing, oil and gas, we've seen use cases where they want to track workers and see if they have their hat on, if they're supposed to be in certain areas in the plant. That's super important for security and safety reason in particular. Same thing, if you don't have the information right there, right now, that's pretty useless to have that the next day. If there's an accident, it's too late. So real-time nature of IoT is really what's driving value. And we'd argue that the time is now. It's happening now. As you've seen, the stats on the 50% of company will see value. We're really seeing it, but it's actually pretty complex. There's still a lot of hurdles to go through. You may be sitting there saying, okay, that's great, real time, it's great, okay, all that, I get it, but how am I doing that? How am I going to apply that to my business? Am I doing the right projects? Am I thinking broad enough? Am I maximizing value? It's all great to think about all those use cases, those business cases, but you oftentimes overlook the complexity of the infrastructure. There's no real standard in IoT. It's not great. It's a pretty fragmented market. Managing an infrastructure, scaling it, securing it, all of that is very complex, and sometimes it causes delays, causes issues. It even cancels launch. We've seen some of those. So choosing the provider for your platform for the IoT deployment is really important, and keep that complexity in mind. Try to limit the complexity so you can focus on the right value for you. We see IoT as a big data challenge. That's really across the board. And if you want to do machine learning and AI, you need a lot of data. Actually, the joke in the data scientist world is, how much data do you need to train a model? 1 billion. That's always 1 billion. You need 1 billion stuff to train a model. That's what they want. So a lot of data to train models and to be able to get access to those real-time insights that are actually accurate. If you want safety, if you want security on your devices, and you have a large fleet, you need to be able to scan that fleet in real time at very high scale. So again, it's a big data challenge. As soon as you start having volume, it becomes a big data challenge. And choosing the right platform to do that, to serve that need, is really, really important. And that's what's going to make your deployment or your implementation competitive or not. So last year, we announced a product called Cloud IoT Core. That was the main component, the main ingestion brick of our Cloud IoT platform. That was in March, I believe, or February. Cloud IoT Core is a fully managed service. Will scale automatically up and down. And it enables you to connect millions of devices securely to the cloud. And then from there, the data will flow in the rest of the platform. I'll talk a little bit about the different components of that platform a little bit later. But the idea is that Cloud IoT Core is your entry point, is your device management. And beside that is all the data analytics, transformation, and insights. One of our customers, called Derive System, implemented IoT Core and the Cloud IoT platform for their deployment. So Derive System is pretty interesting. They're in the $18 billion fleet technology business. They actually equip about 2 million vehicles today and put a little ODB2 dongle into the car to match the engine data and the driver data into a single in single view. Their goal is to really redefine how the cars are configured and operate in the field. It's mostly for fleet. The thing that they noticed is the OEM manufacturer, the car manufacturer, ship millions of cars every year with the same software. It's the same software for everyone. It makes no sense. Nobody drives the same way. Nobody drives in the same place. Different temperature, different way of driving, different frequency, different length. Why all the cars are configured exactly the same? It's definitely not optimal. And Drive System comes with a solution to change that, upgrade the car, and control them better to fit them to the mission that they have. The output of that is higher safety. We'll see an example. Better sustainability with less emission and a lower cost, obviously. So the way they're done is they have that little ODB2 dongle. They plug it in. That connects to IoT Core. Then they use, no, that's just two of the major tools. They use BigQuery. I don't know if you've seen a lot of the announcements for BigQuery during the session. It's pretty incredible. And then cloud machine learning for deriving insights in real time. So they really use that. And then they present all that information through a portal, through a mobile app, through dashboards to the fleet managers. The results was pretty staggering. So let's look at an example that they did. They wanted to limit the dangerous driving for a major fleet provider. So they took two groups, a control group and another group of pretty bad drivers that were doing speed violation quite often. And they plugged that little thing, and they started tracking what they were doing. And as soon as they turned it on and started alerting the drivers about speed limitation, speed violation, it turned out they did 0 speed violations. So that was actually a pretty good result. They didn't need to do any training. They didn't need to do any coaching. And it was just, hey, let's plug that in, and it's right away. I mean, that's pretty impressive. First, it's less accident. That's pretty good. So it saves lives. That's good. They drive safer, so they consume less oil and gas for their car. Actually, the gas gain here was between 8 and 12% per year, which is pretty interesting. And the return on investment just on the cost saving justifies the Drive System implementation right away. So it's actually pretty impressive. So that was very concrete output that we really liked with that use case. So the Drive example is pretty cool. It shows how it could scale. It's 2 million vehicles. It's real time. And let's look a little bit about the platform itself and kind of the flow of data. So as I said, IoT Core itself is serverless and highly scalable. But the rest of the Cloud IoT platform is also serverless. It's fully managed. You never have to configure the scaling policies, the load balancing, the regions. Sometimes it's all included. What you have to focus on is what kind of data do you want and what kind of analytics do you want to do and how are you going to present that. So really focusing on your differentiation and your value. So we'll go through that process of connecting, processing, storing, and analyzing data through a little bit of a journey for data. So let's start with the ingestion of data. I talked about IoT Core. IoT Core has a global front end. And that's important because when you configure your devices, they only have one URL across the globe. You send that device anywhere in the world, it will connect to that URL. But usually when you have one URL, there's a DNS resolution, and the data will hop through the internet to get to that endpoint. With IoT Core, we use the global front ends from Google. So we use over 100 front ends across the globe, and you never really hop across the internet. You always hit the closest front end, the one that serves Google search and YouTube and all that. You hit that, and then you're on our fiber network and go to your region. So you're not hopping through the internet. It's much faster, much more scalable. Then it lands into PubSub. The data lands into PubSub, which is also a global service. That means that if the data is generated in Australia, in EMEA, in the US, when you pull the data out of PubSub, you don't have to know where it was posted. You don't have to know that this vehicle was in Australia or in the US and what topic do I need to get to. You just pull it from the PubSub topic out of your IoT Core, and you just get all the data. So that simplifies a lot. PubSub scales massively. I mean, it's used tremendously inside Google and by our customers. So that's pretty cool. So that data flows in. We even have QoS 1 on PubSub for the data, and there's 7 days of storage included in PubSub for the data, so you can always pick it up later. Then we go in the transformation. Transformation historically was done through data flow, which will scale also and do your job processing over a window of time. We just announced yesterday, I don't know if you saw Cloud Data Fusion in beta. Cloud Data Fusion allows you to do data processing pipeline with drag and drop blocks. They have over 100 of those open source blocks that you can add with sources and destinations and transformation capabilities in the middle. It's all drag and drop. Looks like a big rules engine. Really, really cool. So this actually, Data Fusion is becoming the glue between all the different services on the GCP platform, especially for IoT data. So that's the same thing. It's a managed service. It scales. You don't have to worry too much about that. Then you go into the analysis of that data. So you went into Data Fusion. Fusion's going to drop it into BigQuery. And then you can do all your queries at very high scale, petabyte scale type queries in a few minutes. I think we'll have an example from Birds a little later, who's using a lot of BigQuery. Machine learning will pull the data from BigQuery or other sources and do your training, and then you'll be able to visualize that data through Cloud Data Studio. And there's no IoT value without some kind of act at the end. You can ingest, transform, analyze. Now you need to act. We talked about real-time insights, real-time actions. You need to act on the data. And one good example that we'd like to talk to our customers about is the application of machine learning model to our own data center for the HVACs and how we manage the cold, how to cool the servers in our data centers. When we enabled the adaptive control systems for our data centers, we gained 40% of energy used in our data centers, 40%. It was so big that the team for the data center turned off the machine learning models and the adaptive controls to see if it wasn't something else, and it went back up right away. This is pretty impressive. Our data centers are probably the most efficient already, and that was on top of the very efficient data center that we have. So instead of talking about our own use case, I wanted to bring Ludovic on stage. Ludovic Millier is from Birds. It's a subsidiary of Veolia, so thanks for being here, Ludovic.
Thank you very much.
Good to have you. So tell us a little bit about Birds and Veolia in particular.
Yeah, of course. So thank you very much for being here. Veolia is a French major company with 170,000 employees over 50 countries. They focus on the three main businesses, which are water, waste, and energy. And Veolia clearly take care about how these resources are used. And Birds help them to monitor these resources. Birds is a French company, a Veolia company, as you understood. And we are designing, deploy, configure, and operate IoT devices. We are doing the data collection, processing, aggregates, and delivery of services to our end customers. Our devices, IoT devices, are designed to last more than 15 years, and they are working through a LPWAN network, which is a low-power network, like Sigfox, LoRaWAN, and NB-IoT. We also have our own homemade protocol. Today, we are handling more than 3 million devices. 90% of the devices are used for water use cases. But we also do tank monitoring, electricity, and waste management device management.
So maybe you want to tell us a little bit more about the water usage in particular. What kind of value are you bringing there?
Yeah, so here it is. As you can see, there is a water meter, and on top of it, there is the IoT device. And this IoT device just sends us some data. They send us from alarms. We can be alert on leak detection, which is very important for the end customers. Sorry, we have also alarms from fraud if you remove the IoT devices. Maybe sometimes people think that if they remove it, so they won't be charged, and it's not really the case. And we have other clever people that remove it and turn the meter, fill their swimming pool, and think they won't be able to see it, but it's not the case. We see them. We also have some alarming when meter is blocked and when the meter is under or oversized. But on top of these alarms, so we also have some services coming through the periodic data we receive from these devices. We can prevent sanitary risks. For example, if you have backflow, if you think about something like there is a dirty water inside a private water network, and if this water coming back from the public network, it could be something not very good for water usage. So, and we also can make some temperature analysis. We can also do some network efficiency to see if there's unbilled water. We also can do some consumption forecast using big data or I mean cloud machine learning to have with customer consumption models. We can make some forecasts and also predictive maintenance.
So you're talking about customers a bit. Who's your customer? Can you give us an example of some of the value provided to a typical customer that you have?
Yeah, we have the city of Lyon, for example.
So the cities are your customers?
Yes, cities and cities customers, yeah.
So tell us about Lyon. What did you do?
Lyon, yeah.
That's the second largest city in France.
Yes, it is. For me, it's the best town.
I'm from Paris, he's from Lyon.
Yeah. And we have something like 400,000 smart meters installed in Lyon. And we have a nice use case at the end of January. The weather forecast tells us that we will have a week or 2 weeks with very, very low temperatures, so with a risk of damage on meters, of course. So what we did, we took the data we have on BigQuery. On BigQuery, we have something like 2 years of raw data coming from all these meters, something like 10 terabytes in some tables. So, and we did a little analysis and get all the data, temperature data from this BigQuery table. And we get the list of all the meters which are which we will be under very, very low temperature. And we give this list to the town of Lyon, and they send mails, SMS, and maybe some mails and emails, and to prevent the end customer. Because in France, if the meter has some problem, if the meter is damaged, the end user have to pay for that. So the city of Lyon makes some kind of services to prevent their end customers. So.
Great. That's concrete value.
Yes, it is.
Thank you very much, Ludovic. That's a great use case.
Thanks
for being here.
Thank you very much. Thank you, President.
So you see companies like Birds innovating, and so we're trying to, on our end, we're trying to provide more innovation to our customers so they can build these kind of use cases. What we've done this year, we've launched quite a few features, like the groups feature for devices. We've launched advanced logging. We've launched fast commands down to the device. We can do 100 commands per second to devices also, so we're not just ingesting, we're also pushing that. So we've launched a bunch of stuff, but I wanted to spend time on two major features that we launched last year. One of them is the gateway feature, and the other one is the token service feature. So the gateway feature is something that enables you to declare a gateway in the device manager and declare a bunch of devices behind that gateway. And that enables the first gateway to be a proxy for authentication for those devices. And what that means is you can now connect or identify devices that are non-IP devices directly to IoT Core. That means that if you have a Modbus device or a BACnet device or a Zigbee device, as long as they can generate a JOD token and sign it with their own identity, they can pass that JOD to the gateway will pass the JOD to IoT Core, and the device will be seen as an entity, as a first-party entity. And that's really important because usually when you have a gateway, the gateway does the authentication, does proxy all that identity for the devices, and the devices have less secure identification. With this system, the devices are authenticating themselves and can be seen in IoT Core. That was used by one of our customers called Smart Parking. They have sensors in parking lots, and they have a gateway in each of those parking lots because they also have their mesh network there. And they were mostly seeing the gateway itself, and they were seeing the sensors, but not as different entities. With that, now they see all those sensors as individual entities, and they can act on that. So that was a pretty cool use case. The other service is token service. Token service came from a lot of demand from customers. Customers saying, hey, my device connects to IoT Core. I'm using my public key and private key. That's great. I can authenticate. But now I need to download a patch. Now I need to upload an image in GCS. Now I need to get a machine learning model update because my model drifted. So how do I do that? I need another authentication. I need a Gaia ID now in GCP. So what's the use of having my JOD token? Now I have another Gaia ID for my device. So that's what token service solves. When you authenticate to IoT Core, You get, with your JOT, you can request a token that allows you to authenticate into GCS or Cloud Functions or do any bunch of other services, the container services and things like that, to download or upload data without having to have another identity in the rest of the GCP platform. So it opens up the entire GCP platform to devices through the authentication of IoT Core. So that was a big demand, and that's going to be extremely useful, in particular for models that need to be refreshed on a fairly regular basis, or to do security patches and OTA, for example. We also integrated with LP1 partners. So Ludovic was talking about the fact that Birds is using those LP1 technology. They use LoRa, they use Sigfox. I think you use a bunch of others. So we actually released integration with Sigfox in particular. So if you don't know, they're very low power network. They're a fairly global company right now, and you can have the super, super low power 5-year, 10-year on a battery to connect to the Sigfox networks and then send data to Cloud IoT. And same thing, we did some integration, I think with Obgenius, and there's another one on the LoRaWAN technology, the TTN network. So we have those integration here with the LoRaWAN network. So those are the kind of innovation that we're releasing, and we'll keep going and adding more and more feature. So I want to bring in on stage another customer, Bill Schwebel from Zebra. Zebra, you'll tell us what it is. Welcome, Bill. Thank you very much for being here.
You bet.
So tell us a bit about what Zebra is. What is
Zebra is one of the companies that's probably everywhere that maybe you don't know much about us, but we do barcode scanning and printing and mobile computers that power frontline workers pretty much in most industries, in manufacturing and distribution, in retail, in transportation logistics, in healthcare, field mobility. As a matter of fact, your badge was printed by a Zebra printer, which could have been embedded with an RFID chip. I'm not sure if we did that here, but
probably. Let's say yes.
Yes, of course it is.
Say yes.
You're being tracked. But really what we do is we're connecting those frontline workers into our cloud platform, platform we call Savannah, to create something we call Enterprise Asset Intelligence, and essentially tracking those millions of users, information from those millions of worker users, the assets that, whether they're a forklift or some control equipment, or the goods themselves. So you can think of billions of goods that may be embedded with RFID, may have a barcode, et cetera. That Enterprise Asset Intelligence follows the same trajectory that we talked about earlier with the Ingest, Transform, Analyze, Act. For us, we call it Sense, Analyze, Act. And a lot of what has been happening on the edge has been around sense. And really, for that to have value, you have to go through the other two steps of Analyze, Act.
Great. So you're very much at the edge on local. So how does the cloud play in there? What's the use of the cloud for you?
So the cloud really does two things for us. One is it's the main tool to unlock that data that's on the edge. So that data is trapped today, and it's really that kind of physical world. We've built, and we're building a digital representation, whether it's through the device. So we collect about 250 data points continuously from our devices that tell a lot of things about condition, location, et cetera. But also the other things that you could see, whether it's a visual sensor to look at workflow and how, for example, somebody could be loading a trailer, whether it's assets in a hospital, et cetera. So we use that in kind of facilitating some use cases, whether it's a retail situation where maybe a customer buys something on the internet and they need to pick it up in the store. How many people have gone to a store and the thing's not there? That's a real-time action that needs to happen in that Sense, Analyze, Act to fulfill on that order. Same in healthcare, serving a patient in distress. So that's one. The second is it becomes a key interface point for our ISV partners. We have 2,500 ISV partners, as well as about 10 to 20,000 resale partners. That becomes the interface point for them, rather than having an interface on the edge.
Oh yeah, that's actually a good point. So how did Google in particular, or Cloud IoT, help you solve those challenges?
So we're just beginning our journey with Google Cloud IoT, and we've been doing some POCs. We built our own IoT platform.
That's pretty cool.
Our group has been, we're about 8 years into our endeavor around IoT, but we really looked at it as an opportunity to move into the platform as a service. And one of our biggest challenges is operating on the edge. So most of these facilities, think of a distribution hub or a retail facility or a hospital, they're not on the internet. And we need to do a lot of processing on the edge and then seamlessly be able to take that data, whether I'm running inference on the edge, running models in the cloud, but be able to manage and simplify that, that piece.
Cool. Well, that's a pretty cool use case. I really like it. And thanks for starting with us. Like that's, you know, it's the beginning of your journey.
It's the beginning of the journey.
Great. Well, thank you very much, Bill.
Yeah, thank you.
Thanks for having. It's kind of interesting because you're seeing the mega trend of rapid urbanization that Veolia kind of and birds are tackling. You're really seeing that digitization of workflows happening in the manufacturing 4.0 with Bill. So you're seeing those trends across the different customer use cases. So as Bill mentioned, when you build your solution, a lot, I don't know about you in the room specifically, but a lot of our customers have tried to do it on their own. And that's definitely a way to do it. If you want to build your own platform, you can really build from scratch, from virtual machines, really. I don't advise doing it, but you can. And you can also use the different services, the managed services that we have in the Cloud IoT platform, and build your own solution. That's no problem. A lot of the customers come to us and say, I would like a solution. I don't want just bricks to put together. I want a solution for my use case. So what do you do for agro? What do you do for manufacturing? What do you do for retail? What do you do for asset tracking? Those are all kind of solutions that people are coming to us for. And we've worked with partners to build solution accelerators. We believe that working with partners in that case is actually more important because they know the business actually better than Google. It's more of an infrastructure player. They know the business, they know the verticals, they know the customers. And they can build solution accelerators that are maybe the 80% of what you need out of the gate, and then they'll customize that. So working with partners is really important. In most implementation that we've seen in IoT, there are partners. I mean, it could be on the hardware, it could be on the software that's running on your device, it could be the connectivity partner, it could be the SI, it could be the ODM, could be the platform, the cloud, will be some of the analytics, some of the more vertical players. There's going to be some partners in there. And we see that as a natural fit for any IoT deployment. There are going to be several vendors working with it. So what we're trying to do is work with partners to make sure that we're all integrated. We've done the groundwork before you actually have to do it yourself. So it's cool that you can build the bricks together, but if we bring new solutions from partners, they're already pre-integrated, they're already scale, and they're already using a lot of the benefits of the Google Cloud Platform. So that's really centrally important for us. So you're going to see a lot of the partners coming in. And to that, in that case, I want to show you three kind of solution accelerators that we've seen. So Accenture released an artificial intelligence visual inspection solution. That's really using HTPU that we announced last year. HTPU is our inference accelerator for TensorFlow Lite models that you can run on devices. Tiny chip that goes on a device that consumes 2 to 4 watts only and can do 30, 40 frames per second, machine learning of 30 to 40 frames per second pretty easily on a video stream and apply those machine learning models there. So it's very, very efficient chip that we released. Actually, it's available now. You can go on Mouser.com and buy a module for it. So they've been using that module to do visual inspection. So replace somebody looking at different hardware, having a camera there and doing the visual inspection. They use it on a drone to do power lines inspections as well. And they use it to do analysis of bacteria samples in healthcare as well. So those were usually done manually by a person going up the power line there and climbing. There's risk. It's dangerous. It takes time. It costs a lot of money. This is a much more efficient. So I believe they have a booth where they present that, but you have a visual inspection use case using the HTPU in the show floor that you can see. The second solution is from Deloitte, and they focused more on security. So they have two solutions, the Product Security Manager, which allows you to do a lot of the scanning of applying the patches, scanning the vulnerability of your fleet, knowing which IoT devices is at risk and what kind of patch they have, et cetera. So really having a fleet view of your IoT deployments. And that's really important as every new IoT device is a potential entry point to your network. So the more you have, the more security risk you have. It's not like you have one firewall and everything's behind. You deploy these things in the field. They are sometimes accessible physically. So you have to have a good visibility on security. So Product Security Manager is that. The technical security testing is a solution to do more of the ongoing scans of vulnerability of your fleet. It would be like scanning your web servers or your mail servers to see if there are any problems. They do that for IoT devices. They have robots also going in your, if you have a little data center, they can have robots roaming around looking at cables and see if the layout of what's plugged in here is what you're supposed to be and there hasn't been any changes. So they try to automate. That's really in the workflow automation that we discussed earlier. So those are two solutions. And for the third one, I'm actually honored to have Shashank here from Hitachi Consulting. Shashank is driving digital transformation for Hitachi Consulting. So Shashank, tell us about Hitachi Process Intelligence.
Sure. I'm going to talk about Hitachi and Google partnership, and then talk about the Hitachi Process Intelligence solution. Hitachi, all of you know, is a really old company. We've been around for over 100 years, and we've used the deep expertise and experience that we have gained on operational technology and IT in building these solutions. So these solutions are powered by Google Cloud. And really what we are doing here is helping businesses transform and embark on digital transformation to really drive business, improve processes, and increase agility. Right. HPI, or the Process Intelligence, is one such solution. Anthony's asked me to talk about HPI and take a customer example where Hitachi, partnering with Google, has implemented components of HPI to help accelerate their digital transformation. I'm going to be talking about GrowMark.
Yeah, so it's GrowMark. So does HPI, this is HPI for agriculture. Does HPI work for other industries as well? Or?
HPI specifically for the smart agriculture space. Really what it does is it takes advanced processes. We combine that with analytics to really support IoT-driven decisions for agriculture and livestock industry.
So you have a customer live with this using HPI, and that's GrowMark. So tell us more about what.
So this was a pilot project that we have done with Google, and really we are in the subsequent phases of the project. What we've done here is help GrowMark implement an IoT and an ML solution. What they really wanted to do was to take some of their logistics solutions where they are actually deploying tanks, and these are fuel tanks. Propane, gasoline, and refined fuels. This particular solution is focused on propane tanks. It's an IoT solution where we're actually measuring the tank level, the inventory in the tank, and predicting the demand. So we're forecasting the demand, and we're looking at a 2-day forecast for the level of fuel in the tank. Just to give you some sense for where and how it actually has an impact on the business. GrowMark works with their members, and it's an agricultural cooperative, very large agricultural cooperative. So they work with their members, and they deploy these propane tanks in fields. And imagine having a tank in Sheldon, Iowa, which is a small town of 1,500 people, and 40 miles away from the nearest interstate, right? These tanks actually are providing the fuel in the winter seasons for these farms to for various functions, and as the fuel level depletes, what happens in the traditional way is GrowMark is actually looking at refilling and processing the orders. With this IoT solution, with the forecast that you can get in 2 days, combined with weather data, we are able to predict what the demand looks like, and it's really automating the order and the reorder process.
Excellent. So tell us about how Google helped in that case.
So so I think Google obviously played a big part of the solution. So when we started having the discussion with GrowMark, really they wanted to take the solution, put it on the cloud, and for scalability, reliability, we looked at Google's ML and IoT capabilities, and that was a no-brainer. Really, we actually proposed that as a solution along with Google. And you're really looking at being able to scale the solution and being able to provide some real-time actionable insights using ML.
Oh, great. Well, thank you very much for sharing that story.
Sure, thank you.
That's great. Thanks Shashank for being here. And we're actually getting to the end of the presentation, and I was really fortunate to have real customers coming and talking about their use case. It's always better than more slides. We like to show what's possible on the platform, and what people have done at pretty high scale. We have 3 million devices analyzed with birds, and we have 2 million on derived system. We have Zebra starting to deploy that across, of course, their fleet. Shashank with Hitachi really bringing value to Growmark right away. So this is really great. You can, if you want to learn more, there's a few things in the intelligence neighborhood show floor. There's a little demo of the Edge GPU. As I said, you can write the number of a little roll. It will do an analysis in a few milliseconds and drop it in the right bucket. You can see how a GPU is pretty powerful. Runs on something that looks like a Raspberry Pi, so it's pretty cool. You can find a lot of information online as well in cloud.google.com/solutions/IoT. You'll have more information about the platform itself. And in /IoT/partners, you'll find some of the partner accelerator solutions and some of the hardware as well. So thank you very much for being here this morning, and I hope that was useful for you. And thanks for coming, and I hope you enjoy the rest of the show. Thanks.
Thank you for coming this morning. This concludes our session. Please exit the forum to your right as quickly as possible so we may get ready for the next session. Thank you.
Welcome back to the next live show. I'm Reda Meyer.
And I'm Stephanie Wong, here with Amit Zaveri, VP of Engineering, to dive into APIs. Welcome and thanks for joining us.
Sure, thanks for having me.
So I want to talk about APIs, which have come a long way from the software interfaces popularized by Win32 APIs. Tell us where they are today and your predictions for APIs in 2019 and where Apigee lies in this space.
Sure. I think if you look at what's going on in the industry today, there are many things which are driving the modernization of a lot of the existing applications, right? So APIs are becoming the front end to a lot of the assets companies have already in their portfolio, and they unlock a lot of those content for different kind of users, be it end users, be it partners, as well as employees. So I think if you look at going forward in 2019, you'll start seeing a lot of different ways of exposing those APIs. One, a lot of companies are trying to monetize on them, to be able to kind of use that to create a lot of new content as well as partnerships. So we have a lot of good examples of customers like, say, Magazine Luiza in Brazil, who's trying to create a lot of e-commerce kind of content and be able to expose a lot of data to the end user to buy it. Same thing with AccuWeather, where they want to be able to now take a lot of the weather data and share it and make it available to a lot of other end users as well. So that's one kind of driving factor. Second thing is popularization of a lot of ways of interfacing through voice and text. So you see bots, you see, of course, different kind of consumer devices, and that requires a lot of interfaces into the backend systems and be able to expose it through voice and text. So that's also driving a lot of interest from companies to be able to use API management for that. And third area we've seen a lot of kind of driving factor, and you'll see a lot of it as we move forward, is a lot of industry requirements. Right, so there are a lot of open standards coming out, a lot of regulations coming out, and APIs is the one way to kind of log the content and make sure they're secured and they are available to the right people. So that's another complete new requirement we're seeing and becoming very popular as we move forward.
That's exciting. Now, obviously, a lot of APIs that drive ecosystems are publicly visible, but many of the APIs at any given company are only used internally. How does Apigee support both of those use cases?
Sure. So I think the way we have built our platform in the Apigee area was to really make sure that anybody who wants to expose APIs, we provide them ways to kind of manage the whole process, be it internal or external users. And so the platform is really kind of agnostic of that fact, but we of course provide a lot of safeguarding when it's externally exposed. A lot of the right kind of regulations, the right kind of permissions, security elements are built in. Similarly, inside, when you're trying to expose it inside the enterprise and way to use it between different employees for different application development, again, we provide the whole lifecycle management for it. So there are a lot of, again, capabilities for a developer to use and leverage when they're building those applications, and they can decide the roles and how and what this will be shared. And a lot of features kind of built in to really make that happen.
And a lot of companies are now looking towards microservices, but microservices will continue to have a lot of different recipes. Successful microservice architecture is complex to design, build, and manage, and there are a lot of experimentation going on, but the key is to build reusable, decoupled services that can scale with the right levels of governance. How is Apigee helping to support microservice architecture?
Yeah, I think in general, if you look at the architecture evolution in general, idea is to really have these small kind of services and kind of decoupled in a way. Right? And then the best way to kind of use those services is through an API. So what Apigee does is now that we have interfaces to kind of a lot of the microservices management layer. And for example, Istio, which Google provides as a service, allows you to now expose those microservices, manage them in a much better way, and orchestrate and kind of we do a lot of monitoring around it. And what we do with Apigee is we integrate with Istio and really provide the ability to manage those APIs through one of those one way. Otherwise, if you have other microservices, you have an API, we can, of course, manage that lifecycle for that and allow you to use those microservices in a much better fashion than a monolithic application would be.
Nice. And can you talk a little bit about the new general availability release of Apigee Edge for private cloud?
Yeah, I think the way we are looking at Apigee in general is to have a deployment model which is flexible. Right? So one is to be able to, of course, you can continue using it on-prem. Second thing is to be able to now take it in the cloud. We have an Apigee Edge product which is available in the cloud as well, fully managed by Google. Third is this hybrid mechanism where you can have some of the runtime running anywhere you choose, be it a private cloud or on-premise. It can be running on Kubernetes or GKE. And the control plane is running in the cloud. And that could be in any cloud, could be Google or any third-party cloud as well. So we try to make sure the architecture is very flexible, giving choices to the customers and developers to really deploy the way they would want to. And specifically with Edge, we do provide a private cloud edition where you can run on GKE. And GKE on-premise can be available anywhere a developer wants to choose to deploy it, and we allow you to kind of have it very easy and easy to manage and easy to deploy. So that's available today, and we continue to kind of make progress in that area.
It's exciting. So we know that APIs and building APIs isn't just enough. You have to actually convince your developers to use them. And that means developer portals become key. How does Apigee's developer portal and its enhancements help that happen?
Yeah, I think to tie everything together, you have to have a structure where this information can be available, right? So the developers, of course, would love to have one way in terms of how you manage those APIs, but how do you expose it is through a developer portal. So Apigee provides a lot of capabilities on the developer portal side. So we have a customer-facing portal, a partner-facing portal, all the life cycle for kind of getting your APIs into the portal as well. All the services are available. So developer doesn't have to do a lot of the heavy lifting in terms of how to share that content, how to kind of get right kind of security around it. So the developer portal today is available through all of our products, and we keep on making enhancements to it. There's one offering through Drupal as well, through a third-party CMS if a customer chooses to use a heavy-duty portal and has a lot more capabilities for a lot of specific things, custom work you might want to do. But we also have an integrated portal as part of our offering today, which is very simple, easy to use, and you can create a lot of portal interfaces for end users very quickly and easily.
That's great. Now, Apigee is built on best practice to help create world-class developer experiences, right? So tell me a little bit more about that.
I think in general, just not Apigee. If you look at Google, we've been trying to make sure with the Google Cloud, make developer experience very friendly, right? And I think one of the key things for developer is the life cycle of how do you create an application and deliver that. The one big part of that is the API management for it in terms of the whole life cycle. And so we have made sure for the developer, it's very easy to onboard. They can start writing an API, they can start kind of documenting it, testing it, and design and delivering it. So we provide a lot of tooling for that, very simple, easy to use. And what we've been doing beyond that is really how now kind of giving you metering, monitoring, monetization. So now you have an idea of who's using what kind of securities you have, what kind of privileges were provided to that user, as well as what kind of usage you got out of it, and how much money you can make out of it. So you have a lot of that data available to you at your fingertips. So we've been doing a lot of work to really add a lot of this value add beyond just being able to build an API and deliver it, but also all the things you need around monitoring, metering, security, monetization. So that's really becoming a very powerful element in terms of feature capabilities for developers and anybody else who want to do this work.
Thank you so much, Amit. We packed a lot of info into our talk, so thanks for your time.
Thanks for having me.
If you got a question or comment on APIs, be sure to reach out to us on social media with the hashtag GoogleNext19.
Now let's head back to our showcase for a look at more demos.
customer magic neighborhood with kind of a pretty impressive booth here with NASA and James, the director of NASA FDL.
Yeah, I am. I'm the NASA FDL is an applied AI research lab for NASA. It's a public-private partnership, which is great. So it means we can ask corporate partners who are experts in AI to help us with our problems.
So, with that in mind,
yeah.
How does Google Cloud and NASA FDL work together?
Well, we had a big problem, and the problem was, are we alone, which is kind of the big one, and we knew that you like big problems, so we thought, well, hey, we'll call up Google and see if they can help us. Sure. What's interesting about this problem is we have scientists who are fantastic at understanding the problem, and enormous data, like data you can't imagine how big it is, huge. And so really we needed a corporate expert like Google to help us. And what we prototyped with Google Cloud, with FDL, is the sort of relationships and sort of partnerships which NASA's going to need if we're going to be putting the people on the moon in 5 years. So it's really, if you like, we kind of a toe in the water about how the future should be, just in terms of the way we're solving problems, the way we're partnering. That's what we've been prototyping with you guys, and that's really what Google's amazing at. And I have to say thank you for the help you guys have given, because we did it. We've done some really extraordinary work here, and I think Massey's going to take us through some of the fragments of what was done, and this is what you can come and see at this booth. We're very proud of the work, and just like to say thanks again.
Oh, of course. I mean, it's great to hear. It's super exciting to see this kind of really turn to what can we actually do with this technology? How do we help people? And so we're going to walk through and see what people here at Next can kind of get their hands on and experiment with, and then also see how does that help us answer, are we alone?
Yeah, the team have done a great job of taking something really complex and making it really simple, and you can have a go and play with light curves and finding exoplanets. So there's some really cool stuff to get your hands on here as well.
Awesome, let's take a look.
Yeah, awesome.
So we just talked to James about how the partnership between NASA FDL and Google Cloud helped enable scientists to really start doing this analysis. What can people here at Next actually play with to see what that looks like?
Yeah, absolutely. So the challenge was grandiose, right? Finding life on other planets.
Sure.
So how do you break it down in steps? So step one, you have to find other planets that are outside the solar system.
Right.
So we actually worked on that challenge to start with. And what you can see here is a little bit of a representation of how that works. So the way you have one of these light curves, and the task here you can do is actually, can you actually try to kind of classify by eye, is this a planet or not? So as you can see, actually, it's a quite hard task. You have to kind of understand when things are planet or not, and there are actually a lot of subtleties here. This takes actually a lot of human labor and a lot of astrophysics minds actually spent on this for years. So what we had as an idea is that can we actually have machine learning help us with this? And so we use actually the power of deep learning and AI in Google Cloud to kind of train a model that does this. So the researchers did this actually with our technology. And actually they were able to get a model that is not only more accurate than humans, it can actually kind of process entire data sets in minutes, where before it actually took years.
So people can kind of see the details of why it was so important to have machine learning help out the human knowledge that was required to make this happen.
Absolutely.
So for those exoplanets, can we take a look at those in the mobile apps over there?
Yeah, so here we have a very simple app that you can use to kind of scan the sky, and there are a lot of planets in the sky. And once you point at one of those planets, you can actually kind of study it, and you would get the composition of the atmosphere of that planet. So this actually is more kind of a gamified version of this that represents why is this so important.
So this is a cool way to see and kind of get a little bit of a taste into exactly what goes into making those decisions and understanding all the technology that's required to say, look, we're now making these predictions. Let's see if we can find somewhere and actually answer, is there life out there?
Absolutely. And again, I mean, the beauty of this is that a lot of this work has been done by astrophysicists and kind of astronomy researchers that didn't have a lot of IT knowledge or AI knowledge. They were just empowered by both the power of computation in Google Cloud and by our AI tools to kind of answer these really, really hard questions.
Right, it lets them focus on what's important to them, and the technology just helps enable it.
Absolutely.
That's awesome, thanks so much.
Thank you.
Hi everyone, my name's Natalie and we are here in the G Suite demo booth, and I'm joined here by Ricard, who's from Gant, a customer who had an amazing digital transformation with G Suite. Welcome.
Thank you very much.
Tell us a little bit about Gant and how you opened up a new store with G Suite in 3 months. Amazing.
So Gant is a fashion brand. We have our headquarters in Stockholm today. We're an old company, was actually born in USA from the beginning.
Okay.
One of the things that we did is we brought the button-down shirt to the market.
That's
which
amazing.
You can see all
Fun
over
fact.
Here. Yeah, it's fun fact. So a couple of years ago we had a challenge where we had to open up a new store on Regent Street in London, and we had a record amount of, we had to do it in a record amount of time.
Okay.
So what usually takes 1 year, we had to do in 3 months.
Oh my goodness, so you needed to work fast.
We had to work fast.
So we've actually got Whitney here as well, who's going to take us through a demo, is that right?
That is correct.
Here we have a cool video of the London store actually being built out by the team. And as they were planning, they had a lot of documents going around. They needed to be able to get everyone on the same page, working on the same document, moving quickly together. And so they used to send file versions back and forth all the time, and it really slowed down the process. So they switched to Google Docs, and using Google Docs, they were all able to work together on the same document in all of the different teams across their locations. And they were able to comment each other in, to assign tasks, get inputs from team members across all different locations, and able to just really move quickly together because they were all running in that same document. We're going to move now from our London store team to the Stockholm headquarters team.
Okay, so now you're going to show us what the Stockholm team was doing for inventory planning, right?
Yes, exactly. So we've just moved into the Stockholm headquarters where the team was also working really hard to prepare for the London store opening. And they were focused mostly on planning all of the inventory that was going to be needed for the new store. And so in order to do that, they needed everyone working on the same spreadsheet, planning what was going on, planning where the clothes were coming from, how much we needed of each item, things like that. And the same way with Docs, that they were all able to collaborate live on that one document, they were able to do the same thing on the spreadsheet, which helped them move really quickly as well. And they also used a feature called Sheets Explore, which allows people to ask questions about their data in natural language so they can get insights from their data, like what's the average price per quantity and things like that. And that way they're able to get all of the information they need to plan really effectively.
Through actually asking, through voice, those types of questions, it's awesome because a lot of people businesses don't necessarily know how to write SQL or complex queries. The Sheets Explore tool is amazing for that.
Yeah, no longer do we have the headaches of creating all the pivot tables by hand, but rather you can just go in and get those insights from your data right away.
Great. Okay, now we're going to imagine we're in another country, right?
Yes, we've made it to Portugal where the Gant manufacturing facility is located. Quick trip. And so the team here was working really hard to create all of the clothing that was going to be needed for the store. And so they were hard at work in the manufacturing facility, really to make the best items they could. But they needed to get approvals from the London and the Stockholm teams who were doing the designs and wanted to make sure it was the quality they were looking for and things like that.
Sure. And sometimes those decisions just need to be made face to face, don't they?
Yeah, exactly. And so the Gant team used to fly people to the manufacturing facilities to check out the clothing, make sure it all looked good. But now they've really switched to using Meet, which is G Suite's video conferencing solution. And using Meet, they're able to get everyone in the same room virtually so they can still see the look and the feel of the clothing. And so now I'm actually going to have the opportunity to show you how they would do that. So we're already hooked into this meeting on our computer, and I'm going to show you how the team in the manufacturing facility is able to join with one click from the phone, and then they actually will walk around with the phone and join the meeting and be able to see the clothing, get a feel for it, and this way get all of the approvals they need for the clothing.
Amazing. So it's, you get the feeling that you're actually in Porto, although you're in Stockholm or London.
Yes.
That's amazing. Well, thank you so much for this walk around. This has definitely been one of the most interactive sessions and demonstrations. Thanks, Whitney.
No problem.
And Ricard, also, I guess, the G Suite technology is amazing, but I'm assuming this just meant so much for your customers to be able to move from producing a store in 1 year to 3 months.
It did. It was a record time, and we ended up with happy happy customers, definitely.
I'd imagine you did. Thank you so much both for joining us.
Really appreciate it.
Thanks, and back to you.
All right, thanks team. Coming up after this next round of sessions, a lunch and learn on building amazing apps with Cloud Firestore, and we'll have a live demo on service monitoring with Stackdriver. Stay tuned, we'll see you in about an hour. You're watching the next live show from San Francisco.
please welcome Developer Programs Engineer Google Cloud, Chris Wilcox, and Developer Advocate Google Cloud, Dustin Ingram.
Thanks, everybody. Hi, I'm Chris. I work at Google on the Google Cloud Client Libraries. I focus on the Python language and our storage and database products.
And I'm Dustin Ingram. I lead Google Cloud's Python advocacy efforts across all of our products and our services. We're going to talk a lot to you today about motivations, specifically things which might motivate you from, or be motivating you, to migrate from Python 2 to Python 3. But first, let's take a step back and talk about what likely motivated you to come to this talk. You're probably not here because you're trying to choose between Python 2 and 3. If that was it, this would be a very short session.
And if that's why you're here, I can help you out. The answer is Python 3.
You might be here because you have a Python 2 app running on Google Cloud, and you want to use some of our newer products with Python 3 runtimes like App Engine or Cloud Functions. Or you might be here because you have Python 2 running somewhere else, on another cloud provider or in a data center, and you want to migrate that to Google Cloud as well. So we're going to cover all these use cases today. So here's a look at what we're going to discuss in this session. We'll briefly touch on the current timeline for Python, why we even have this problem in the first place. Then we'll talk about some general things that are good motivators for migrating from Python 2 to Python 3, followed up by some common migration patterns that you can use today. And finally, we'll talk specifically about some Google Cloud products and about ways that you can enact this migration in your organization today. So let's look at the timeline for Python. And we'll break this up into the timeline for Python 2.7, which is the current latest version of Python, and for Python 3, the current latest version of Python 3. So Python 2.7 was released July 2010, which was almost 9 years ago. In terms of Google products, we got a 2.7 runtime for App Engine Standard in 2012. And in 2017, we got a 2.7 runtime for App Engine Flex. The latest version in the 2.7 branch, 2.7.16, was released earlier this year, and there are 2 more bug fix releases planned for 2.7. 2.7.17 in 2019 and 2.7.18 in January 2020. The 2.7.18 release will be the last release of Python 2.7 ever. And after this, the Python version will be at end of life, meaning that it will no longer get bug fix or security releases from the core development team. So if that seems really soon to you, consider that the end of life was supposed to be 5 years ago. I can guarantee that this extension won't happen again. Python 3, on the other hand, was released December of 2008, which means that it was actually released before Python 2.7 ever existed. We got Python 3.5 in 2015. And Chris jumped the slide. Yeah, we got Python 3.5 in 2015 and 3.7 last year. And for Google products, runtimes for those versions followed shortly afterwards. And for App Engine, the 3.7 runtime was generally available only a few months after 3.7 was released. And that led to this really great tweet. In case you didn't know, Guido van Rossum is the creator of Python, and he used to work on App Engine as well. So he is particularly excited to see that there's a Python 3 runtime for App Engine. And in case you didn't detect it, he's also being a bit facetious here. There's definitely a number of reasons why you might want to stay on Python 2. So we'll talk about those here shortly. But first, let's start here. What is all the fuss about? What is the actual difference between Python 2 and Python 3? Essentially, there are a lot of breaking changes between the 2 versions. It's still the same language, obviously, but both forwards incompatible and backwards incompatible changes exist in the 2 versions. And this means that what you could do on Python 2, you can't do on 3, and vice versa. There's also a lot of new features, but the important stuff is definitely the breaking changes. So generally, as developers, we try to avoid breaking changes, right? Couldn't this have been avoided? Not really. The core Python developers explicitly needed to change some fundamental things about the language in order to ensure its long-term success. And while migrating between versions and introducing breaking changes is always a challenge, the decision contributed to the overall success and health of Python that we see today. Obviously, that's a little bit of speculation, but I really think that these changes helped course correct from some earlier design decisions that would have left the language to stagnate. and would have caused bigger issues if they had been ignored. The core issue is that Python 2 didn't have great support for dealing with strings in encodings other than ASCII. Essentially, this meant that it did not serve languages well with special characters, not as well as we'd like it to anyway. Changing this required changing the way the strings worked in Python. And since strings are a fundamental type in most programming languages, as you can imagine, this required a breaking change and would have essentially been impossible to do in any other way. However, the Python core developers figured, hey, while we're making this breaking change, let's go ahead and make a bunch of other breaking changes while we're at it, without having to do a deprecation process. And so I'll talk about some of these other things that they wanted to fix in a minute. Let's talk about motivating your own migration. We'll talk about some things that might motivate you to move from Python 2 to 3, and we'll address these in the order from least motivating to most motivating. So first, least motivating is new features. In the intervening 10 years, Python development has continued, surprise. And this has resulted in some new features in the language which often got brought up when talking about differences between Python 2 and Python 3. So the first, like I said, the big one is Unicode. No more confusing byte markers when we wanted accented characters. No need to specify separate types for string and for Unicode. Instead, all strings in Python 3 are Unicode by default, and they can be encoded into bytes whenever you want. Next, there's an improvement to integer division. So this is one of the things that the Python maintainers wanted to fix and sort of lumped in with the 2 to 3 change. In Python 2, when you divided two integers, you got another integer. And this was kind of confusing and introduced a bunch of weird bugs when folks expected sort of what a calculator normally does, which is give you a floating point number. So starting in Python 3, dividing two integers will always give you a floating point. Another one is new style classes. So this is really small, but it also required a breaking change. In Python 2, when you define a class, you always need to specify that it inherits from something or the base object. In Python 3, this saves us a few keystrokes, and we can implicitly inherit from object when we don't define a parent class. Another sort of nice feature that came along with the Unicode support is in Python 3, you can use text-like Unicode characters in variable names. So you can set pi as your variable name. You still can't use emoji, though, unfortunately.
Another very popular feature that came along in Python 3 were f-strings. And this provides yet another way to format strings in Python. F-strings brought string interpolation to Python. And this is very popular in a lot of other programming languages. It's popular because it tends to result in more human-readable and less verbose format strings. And finally, Python 3 brought a whole host of new standard library modules for us to use as developers, each individually, which is incredibly useful. And they're not available in Python 2. OK, well, anyone that's used Python 2 knows that's kind of a lie. A good amount of these have been like unofficially backported, but they're in Python 3.
So all of these things are great, and they will actually make your developers' lives easier. However, they might not be so motivating to you that you want to migrate your massive Python 2 code base right away. So if you really need some new feature in these modules, you could probably just backport it, like Chris said, with less effort than migrating your whole code base. And you've probably also done with a lot of these other niceties like f-strings and stuff for so long that you don't really actually care about it that much. So, OK, how about new products? Maybe slightly more motivating than new features. You might be motivated to migrate to Python 3 because you want to use some new product that doesn't support Python 2. So you might have noticed that some of our newest products and latest releases all support Python 3. So Cloud Functions only has a Python 3.7 runtime, along with some other languages as well. And App Engine just got an idiomatic Python 3.7 runtime too. And there are other examples in the ecosystem as well. And generally, you should expect that these new products have some new interesting features in addition to just having a Python 3 runtime. For example, both Cloud Functions and App Engine let you auto-scale your app instances down to 0. That's something you can't do with the old App Engine. And if you're unfamiliar with the first generation App Engine runtime, you'll appreciate the idiomatic way that the 3.7 runtime lets you specify dependencies with just a requirements.txt file. So overall, you shouldn't expect a cloud provider to be offering new products that support Python 2 anymore. And if you want to use the latest and greatest, you'll probably want to migrate. But this might not be very motivating either. What if you don't really care about the latest and greatest, right? Your existing Python 2 App Engine app is running fine. It still works, and you're used to the way you have to vendor in your dependencies every time, right? It's fine. Well, let's talk about those dependencies for a second. I'm assuming your application has dependencies, right? If not, I would be really, really impressed. So just by the very nature of them being dependencies, they're by definition somewhat out of your control, and definitely out of the control of your cloud provider. So this means that you have little or no influence on whether they're going to continue to support your use case. And if your use case is, it works on Python 2, well, the days of you being unsupported might be a little closer than you think. A number of major projects have announced that they will no longer support Python 2 after the end of life. Client libraries for Google services have also announced that due to gRPC dropping support for Python 2, they will be as well. Now, this doesn't mean that these libraries and dependencies and modules are going away. The existing libraries and the existing versions are here to stay, totally frozen in time. And the runtime itself is a similar story. It's not going to receive new updates and will also be stuck in time. However, do you know that one thing that you can't freeze, though? The security of your runtime.
So today, you exist in a supported ecosystem. If a CVE comes in, zero-day vulnerability, there exists a team of core developers waiting to pick that up, support the community, and make sure you're covered. And these issues, they don't arise all that often in Python, but when they do, they need to be reacted to quickly and by people who understand the system well enough to fix them. So let's look at some CVEs. This one happened in December to Node.js. This particular vulnerability allowed overwriting buffers and posed a real risk to deployed applications. The supported versions of the runtime were patched. How about a more recent one? So less than a month ago, Rails found two separate vulnerabilities that together were pretty bad. There was a remote code execution path, and there was a denial of service that was able to be used by taking access of some ways that Rails interprets unknown types of files. And they patched the versions quite swiftly. This was all taken care of in a few days as far as the public was concerned. For the versions that are covered, you'll notice that 4.2 is there, but there is no 3. I think it's probably fair to say that most of us in this room and in the technical community aren't really security experts. We have some other concern, a product, a service we care most about. We don't really want to own security of our platform. I mean, some of us try to vendor away security of our application, right? Like owning the runtime is on a whole other level. So we see this kind of as a distraction. And so this distraction is going to become your problem if you stay in Python 2. In general, communities have platform-specific frameworks that are very important to their success. So Rails exists in Ruby, and there exist very similar things in Python that could have this exact issue. And those frameworks have already announced that they're not supporting Python 2. Their latest versions aren't supporting Python 2. So this is probably going to happen, not in this exact shape, but it's going to happen. So do you want to be concerned with this and take on this burden? Probably not. I doubt that tomorrow you want to start monitoring for CVEs. I doubt tomorrow you want to be the person that fixed Python. And I doubt you want to be the one working on the web framework fixing the issues it has. So the longer you wait, the more that responsibility shifts from a community of people who are experts in that space to you.
So slightly more motivating than even runtime security is runtime support, or perhaps the lack thereof. So if you currently run your Python 2 application in a hosted runtime, you can't really expect that runtime to exist for all of eternity. There isn't going to be a Python 2.8. In fact, there is a Python enhancement proposal called PEP 404, titled the Python 2.8 Unreleased Schedule, which explicitly states that this is never going to happen. So the more that you depend on Python 2 and the longer that you wait to migrate, the more likely it becomes that you are going to become an edge case, and the services that you depend on might eventually get turned down. And finally, the ultimate motivator is cost. So costs are going to go up. As more users migrate away from runtimes, runtimes will become more rare and expensive to maintain. And your developers are also going to want to use Python 2 less and less. You're going to have to pay them more to work on an old Python 2 code base. And you don't want to be an edge case. Like, this is not a good place to be. It's generally going to be expensive for you, and it's going to make you a weird user.
So I hope after hearing us talk a bit about why you should be motivated to move to Python 3, you're all very excited to start this work. OK, yeah, that's probably not true, right? You're in this room. There's 8 months left. You're probably not excited about it. But you're maybe a little better informed. So let's move on to how we might actually go about migrating an application from Python 2 to Python 3. We can start by discussing a suggested set of steps you might take. And what I've done is I've kind of looked at past talks I've seen. We've been talking about this for, I think it's safe to say, about 5 years now. And there have been a lot of different talks, and they're all a little different. And so what I did is I formed what I think of as sort of the canonical suggestion from all of these talks, and I narrowed it down to 7 steps. So you start by verifying that all the dependencies you rely on work on Python 3. And then invariably, they all say that you should make sure your test coverage is good, because then we can confidently migrate. And then we should drop support for versions of Python older than 2.7, because there's a bunch of other idiosyncrasies we'll have to deal with. So if we do that, that'll make it easier. And then we'll go to Python 2 to 3. And then we'll change our runtime to Python 3. Then we'll remove the compatibility layers we used to do all the stuff that we just did up above. And then we'll drop support for everything. The problem is this might seem reasonable, but also makes this process seem really scary. And a lot of these things they're kind of hiding crazy expectations of any sort of development team. They're also kind of focused on libraries. So most of the talks I've seen on this before have focused on the Python community and have talked mostly about people that are hosting PyPI packages. And the concerns of someone that deploys a library to a community are entirely different than someone who hosts a service. So let's talk about some of these anti-patterns. First of all, I want to talk about this 100% code coverage to make migration easy. It's highly unlikely someone at this point that's looking to migrate from Python 2 to 3 is going to stop developing their application to handle the technical debt of testing when they couldn't handle the technical debt of moving their platform, right? That doesn't really make sense. Further, unless you can put a lot of effort, it's unlikely this is even going to bring you the confidence you need, right? Because we're not really talking even about like line-by-line coverage here. We're talking about a bunch of scenarios that we may or may not know. And that's kind of unreasonable to expect people to do, but it's constantly said, oh, if you have a good test system. OK, so next. We like to talk about talking about earlier versions of 2 than 2.7, so let's say 2.6. So 2.7 has a lot of backported features and things that came in that made it a little easier to move to Python 3. And if you're on 2.6, there's a larger canyon sort of to bridge here. But I don't really like talking about this in regards to going Python 2 to 3, because this is a hidden migration all of its own. And trying to tackle them together probably isn't the best approach anyway. If you really are that out of date on your Python 2, that you're not even on the most current version of it, why are you trying to jump to a major version beyond that? And lastly, these last 2 steps have nothing to do with migration, and they have everything to do with improving the maintenance burden of our application and making things more sustainable. We don't really have to remove compatibility layers. An internal service that hasn't migrated yet likely isn't going to be bothered by a little bit of glue code that makes our stuff work. So it's not really a big deal. It's not a burden to support. That surface is unlikely to be moving. It'll be fine. Also, the idea of dropping support for less than 3.5. For a library, this is an exercise in sustainability of an ecosystem. If I have to keep supporting Python 2 and Python 3, that's more work for me. You own your application. You own whether or not it's on Python 2. The idea of somehow making it not work on Python 2 doesn't give you anything. Where with library maintainers, that gave us something very real. That freed up our time to look at new features. So after these reductions, what we're left with is a 3-step process that I think more accurately reflects what a migration is. We verify our dependencies work on Python 3. We make our library work in Python 2 and 3. And we change our runtime to Python 3. And we declare victory.
So we've talked about the process that we're going to worry about undertaking, and it's fair to say that a majority of the efforts to migrate are going to be in porting to a Python 2 and 3 compatible layer. So let's get into a little bit about how we can accomplish that. We're going to talk about some of the popular tools used for migrating, including 2 to 3, 6, and Future. So 6 and Future are compatibility libraries. You would import from these in your code, and they're modules on PyPI. And 2 to 3, Modernize and Futurize are migration tools. So these are command line tools that you can run that will do some of the manual work of migrating some of your code. So to get a better understanding of some of the tooling available, we're going to look at some examples, and let's just start with a Python program. So at the top level here, we have a request for user input, and then this is provided to a method which takes a parameter name and prints a formatted string. So let's look at the diff after running 2 to 3. It's taken care of a lot of the work needed to convert from our Python 2 program to Python 3. Starting at the top, you'll notice that print has been replaced by a function, and the other change is that raw input has been replaced by input. 2 to 3 ships as part of CPython, which is the reference implementation of Python that almost everybody uses. It handles a good deal of the conversion necessary to move to Python 3. And it's extensible, so if you wanted to customize it for your use cases, you could do that too. However, it has one large downside for most applications, and that is that it doesn't maintain backwards incompatibility. What has changed your code to here is not going to run any longer on Python 2. So I know it seems maybe a little bit odd to be concerned about backwards compatibility, since the goal is to move away from Python 2. But often moving everything all at once is really difficult. It's essentially like a full stack rewrite. So being able to simultaneously support Python 2 and 3 at the same time means you can slowly migrate, slowly change your code line by line, file by file, while continuing to use your application. So let's look at some additional tools that try to fix this weakness in 2 to 3. So another option is using the 6 compatibility library via the Modernize tool. So after running the Modernize script, your Python script is altered. It now imports some additional functionality to bring Python 3 support into Python 2 and alters the syntax to be Python 3 compatible. And then it also corrects some other small differences, such as using input instead of raw input. So now this code is both valid for Python 2 and for Python 3, and it will have the exact same behavior in both runtimes. This is great. The third tool is Future, which is really similar to 6. And they're actually similar enough that the code shown on the previous slide for both Modernize and Futurize will output the exact same thing. So one unique feature that Futurize brings that Modernize doesn't have is the concept of a staged migration. So this can help making the process of moving to a new runtime a little bit less daunting to the migrator.
So at Google, on the client libraries team, we leverage Future. We've been supporting Python 2.3 for quite some time now, and so this is how we do it. There's a choice you have to make, and this is going to be personal. Both 6 and Future are very capable libraries. In my opinion, from my experience I've had, Future's a little more thorough, and it goes a little farther than 6 does. But ultimately, that's going to be up to you. Because they are similar enough, though, rather than showing you a bunch of repeated slides, we're just going to show the Futurize examples. But 6 is very, very similar. So let's look at a few more examples. Let's start with a simple example. Earlier, we talked about integer division, and that it's changed between Python 2 and 3. So something as simple as a division operator changing between these two runtimes could be pretty disastrous for our code. So we're going to have to apply some sort of small fix via our modernization tools. So in Python 2, this is a one-line example to divide 3. And then what we have to do with Future is import division, and then import old division. And then old division 2, 3 is a method that replicates what happened in Python 2 for you. And so when you run Futurize, it does this to your code for you. And now you don't suddenly get surprised by bugs that happen because you moved to Python 3. But let's look at something a little more complicated. So we use iterators a lot inside our Python code. Here's a basic sample that imports the config parser, which is a built-in module, and has a class upper that implements a next method. And then at the end, we instantiate upper, we request next, and we print it. And because there's a comma at the end of that print line, we're not going to have the new line. So, all right, well, what does this What does this look like in Python 3 now? So one of the common side effects of these tools is a drastic increase in the amount of imports we have. Lucky this is mostly noise, and it doesn't cause that many problems, but it's worth pointing out. But what are these imports all doing? So first of all, we get the print function, which means now in Python 2, we can use a print function rather than the print statement. We import the standard library from Future. What this starts to do is allow us to alias some of the behaviors from Python 3 and start using them in Python 2. The benefit of this is while you're migrating, you can start to take advantage of the cool things in Python 3, at least a little bit, and sort of warm up to how that works. We also import a built-in for next. And at the very bottom here, config parser is now all lowercase. And this is because when Python 3 was made, they took the opportunity to rename a bunch of the built-in modules. And so this is one of the changes that happens. Futurize knows that, and so it can make that transform for us. So here are the code changes. Next is a dunder method in Python 3, so that change is made. And this is why the built-in for next was previously imported. This will work in Python 2. But it's in the style of Python 3 for you, so you start to take on the new style of the language rather than just having Python 2 run on Python 3. The other change is print, and there are two parts. First of all, it's now a function call instead of being a statement. And also, we've brought on the end argument instead of just having a comma followed by nothing. So it's very similar, but it's a little different also, right? So one last example. Let's look at how comparators work. So here's an orderable class that has a first name, a last name. We have a comparator implemented, and we call sorted on the end with a list of two things. It's pretty basic Python 2 code, nothing too surprising. So how does this look when we go to Python 3? So I'm going to stop. Before I show you that, I would like to talk about a rather big change. So the old way of doing comparisons in Python 2 was you implemented this comparable operation that returned an integer, letting us know something coming before or after was the same. And this is not uncommon for a lot of programming languages. But when they went to Python 3, they implemented rich comparison operators. And so these are the methods you now implement to describe comparisons. They're not all strictly necessary. For instance, if you don't implement any, not equal, Python assumes that it's equivalent to calling not of the equal operation. So what do we do to make this work then with Futurize? And this seems like a rather big change. It's probably hard for tooling to get that right. So what we do first is we import from the past the CMP operation. And then that's all we do. So this is the sort of thing where Futurize really starts to save you. Because now at this point, you're moving to a whole new runtime, and you don't have to figure out a whole new way of doing comparisons. You can just add these lines and keep using your own code. And moving forward, it's probably best if you don't keep doing this. But it's also probably better for you not to have to go through the work of trying to alter the entire way all of your classes work just because of this migration.
So these tools are actually really impressive in what they can accomplish. They handle a lot of the boilerplate of moving from 2 to 3. With that said, though, they are not magic, and they do have some shortcomings. So it turns out there are multiple ways in which it will always take a human to make a decision about what to do with your code. So we're going to look at some examples of those shortcomings now. So here's an example where the tooling can struggle. On the top, we have a totally valid piece of Python code that sorts an array. In Python 2, this returns a sorted array. The code in Python 2 is perfectly fine, but in Python 3, this will raise an exception. And in fact, there isn't an obvious way to make this code valid in Python 3 at all. Python 2 will implicitly sort this list regardless of type. In Python 3, it is required to have implemented comparisons between disparate types. So if we step back a bit, maybe that Python 2 result is actually a bit unexpected. And now if you look at the sample, what is the sort ordering that's being used here, right? Without more information, we could come to some conclusions. Like maybe what's happening is that 1 is being coerced to a string type, and then it's being compared. And so numbers come before letters, and that might make sense, right? So let's change the example a bit. If we instead make 2 an integer, we find that the sort order isn't the same. So type coercion is probably not what's happening here. What's actually happening is that Python is comparing the types themselves. str comes before int lexicographically. So that's how they're sorted. And this is deterministic, but if we're being honest, it isn't an obvious way to sort disparate types. So Python 3 decided, I want nothing to do with this, and will not support such things. And this wasn't necessarily expected by programmers, and needing to make this a bit more explicit required comparators and helps clarify how all this works. What if I want to make this example a bit less weird and replace 3 with just the number 3? So now looking at this code, it likely gives you sort of a different feeling. It seems like maybe we accidentally added the string representation of 2 to this list of integers. So 2 seems unusual now, and is likely, that's probably a bug of some kind. And if this was Python 2, we would have no idea that this bug existed, because it's totally valid. But since Python 3 requires that these be all the same type, you need to be a bit more explicit about how you want to order these elements. So this example shows that the tools can't always help you when you try to do something that is strictly unsupported in Python 3, or might actually be a bug. Code often has elements in it that aren't machine comprehensible, and in these moments, a developer is always going to have to step in and help guide the system. So let's look at one other example. In Python 2, if you indexed into a byte string, it would return the character at that index. Python 3 will instead return the integer that represents that byte. So you can see that in Python 2, there's easy confusion between byte data and between text data. And the Python 3 makes a hard line on saying, like, no, this is just byte data. In general, you will find that these tools don't tend to handle these issues that would arise from byte data and text data. You're going to have to reason through every instance of this using the information in your application. Only you will be able to actually determine if it's byte data or if it's really text. As a sort of extension of that previous slide, in Python 2, if you tried to convert an integer to a byte string, what it does is cast the integer to a byte string, and you get the byte string 7. In Python 2, that's just a string. However, in Python 3, this gives you a bytes object of that length, initialized with null bytes. So these are 2 completely different values. Python 2 allows us to use strings to store text and binary data. And the lack of clarity on whether a given method is going to accept binary or text data or supported Unicode, it became a pain point as we entered into the age of the internet. So Python 3 was an opportunity to bring Python in line with the expectations of the world which we're currently in. Binary and text types are better separated, and the core of the issue is that in Python 2, there isn't really a way to know what this encoding is going to be. So there are multiple ways to move forward in breaking apart text and binary data. This is a relatively deep topic. You could almost make it a talk of your own. So let's lay out some basic ideas to start with. First, you need to understand what your objects are and understand the types that we expect them to be. You should audit anytime you try to open a file. Because of the default changes on the open method between Python 2 and 3, it's likely wise to always specify the encoding and bytes or textual access modifiers. You could also consider using io.open to get a consistent interface. This is another effective way to mitigate issues arising from defaults on file opening being different. So it's likely that your application has some places where these things are a little bit muddled. You're going to have to be the decision maker, and the tooling is going to have to stay out of the way. This is typically an area where people state that they had the most difficulty in migrating from Python 2 to 3, because it isn't just a matter of changing syntax. You need to understand your program and what the data inside it is meant to be. So let's wrap up with what you can take away from these examples. We don't have a magic tool, and that's for a good reason. Many chunks of code that we work with contain these little small bits of human understanding, and a tool is never going to be able to understand that. It's never going to be able to simply transpile from Python 3 for you every single time without a problem. Sometimes these tools are going to make changes that expose bugs, introduce new bugs of their own, and so while they're really useful, they can also be a little bit dangerous, and you should use them with caution. The changes that they make should always be reviewed and considered more deeply by a human, a real developer, with understanding of how the code base works.
So we've talked a bit about the timeline for Python, how you might migrate to a 2.3 compatible code base, but let's talk a bit more about Google specifics. So if we reflect back on why you're here, we have 2 groups that we're interested in targeting, because we've already assumed that you don't really care to know what's great about Python 3. Both these groups have something in common, in that they're trying to move to Python 3 with their applications. And for this talk, I'm going to make the bold assumption that you're looking to do this on Google Cloud. And we can make this a little more specific even. Most people right now that are using Python 2 on Google Cloud are probably using App Engine. And so this section is going to be most relevant to those folks. So if you're an App Engine 2.7 customer, this is for you. It's likely interesting to other people, but that's the group I'm most interested in informing. Today you have multiple options. This is not comprehensive, to move off of App Engine 2.7. You have other App Engine runtimes, you have containerized environments, and this is a choice you get to make. These each bring pros and cons with them, and I can't possibly make this decision for you. But it turns out, in terms of the pain points you're going to have, they're all basically the same, regardless of which application you're moving from. And that there are things about the App Engine 2.7 platform that you've likely taken a dependency on, whether knowing or unknowing, that you're going to have to deal with. So let's go back to our original three-step process we're following and modify it slightly. We specified dependencies before, and I sort of just skipped over the fact that that is almost always phrased from libraries, so we're talking about Python dependencies. But you likely have dependencies of services. So in the case of App Engine, there are services you rely on that won't exist outside of the App Engine environment. And so you need to migrate those dependencies in addition to the Python dependencies. So let's look at some new services. These are services that exist outside of App Engine 2.7 that you can start using that will replace, mostly identically, but with changes at the edges, between what you were doing on App Engine 2.7 and you'll be doing in the future. So first off, let's talk about Google Cloud Tasks. One of the things that is in App Engine that a lot of users rely on are task queues. Task queues were built into App Engine, and moving forward, that's not really how we build applications. App Engine was this monolith that had all these things in it, and now we're expecting that you'll have other services you rely on for this sort of behavior. And Google Cloud Tasks solves this. It was recently made generally available to the public. It supports most of the same use cases as Tasks did inside App Engine. But I feel it's important to be honest about some of the subtle differences that we're going to have. So if you're using pull queues today, which is a feature of task queues, that's not supported by Google Cloud Tasks. However, it is a very good fit for PubSub. And you're going to find that across a lot of these changes, that's the case. That when there's not a one thing that does all of the things the other thing did, maybe there's two products. And so this is a case where that happens. Another thing that isn't supported are transactional tasks. So if you're using those, you'll have to consider how you're going to re-architect your system to handle that. I can't exactly tell you how to do that, but that is going to be something you're going to run into. The other one, it's a little more subtle. Task queues had a concept of deferred tasks. And there's a close equivalent in Google Cloud Tasks in that you can schedule tasks for the future, but deferring something and scheduling it at a future date aren't exactly the same. Though for the most part, you can probably use them to solve the same problem. Also, and this is kind of a big one for a lot of people, this doesn't have nearly as good of emulator support as the existing App Engine did. So the App Engine 2.7 support over time developed a very good emulator for which you to work on locally. And a lot of these new products, that's not the case. They're not one monolith, all enclosed. They're multiple little services. And so if your development process is heavily relying today on this emulator, you're going to need to consider ways to minimize that. There are other approaches to use other than emulators, but that is going to be a surprise. Another really popular App Engine product was Memcache. And Memcache, again, was built in App Engine. Moving forward, Google Cloud Memory Store solves most of the same problems. This, to some people, seems less obvious because Memory Store is Redis at the end of the day. It's this big thing, and Memcache seems lightweight. But if you use Redis at the level of Memcache, they're compatible. It just doesn't quite make sense sort of to the way we think. But you can totally use this as a slot-in replacement with very, very little changes to your code. It's pretty straightforward. So the last product, and this tends to be a big one, is Data Store and App Engine. So most customers in Python today are using Data Store in some way, and a lot of you are probably using a thing called NDB. NDB, as of today, doesn't support Python 3, and that's a big problem because not only are we asking you to migrate from Python 2 to Python 3, we're asking you to change how your ORM works inside your application, right? NDB, I would go as far as say it's an ORM, right? And so what we've started doing at Google is we are working on NDB for Python 3. And to be just completely transparent, it's very difficult because there are a lot of assumptions in NDB about the way App Engine 2.7 worked and the way it interacted with Data Store. But because we have Google Cloud Data Store, as well as Firestore and Database Data Store mode, we can support you. And so we're actively working on an alpha. We hope to be able to release it soon. And if you go to GitHub, you can find our project and watch it being developed. So I also want to mention, I just kind of casually mentioned Firestore. So moving forward, Google Cloud Data Store isn't the recommended approach. The recommended approach is to use Firestore, which has a Data Store mode. So if you're a Data Store developer, it's a lot more comfortable. I just wanted to point out some of the reasons you might consider doing this. And there are 3 big ones for me. The biggest one, though, is that Data Store is eventually consistent. And eventual consistency can kind of be problematic as a developer and can introduce some fun problems in our applications. Firestore is strongly consistent. And so that goes right away. You don't have to worry about that anymore. And so for me, that's very convenient. The other 2 things I can kind of lump together, both transactions as well as right to entity groups, are more capable than they were in the original Data Store.
So Python 2.7 support from the Python community is ending January 1st, 2020. And while that date is rapidly approaching, Google is committed to supporting App Engine customers using Python 2.7 beyond this date for many years to come. Migrating a Python 2 App Engine application to Python 3 will require many updates, ranging from the language level to the GCP API integration level. And so we're prioritizing documentation, tools, and infrastructure updates to make this transition as smooth as possible for our customers. We know that the Python 2.7 to 3 migration will be a long process for many people, and we're committed to supporting that migration and making it as easy as possible for you. That said, we do want you to migrate. It's best for you, it's best for us, and it's best for your users as well. Okay, so maybe you're still not convinced. Maybe some of these sound familiar, but I have too much code. But I have too many dependencies. But nobody wants to do it. But it works fine right now. But I haven't upgraded anything since I wrote it. When you're going to have a crucial migration like this to make? And how do you learn from those migrations in those situations? So instead of you looking at this as a burden, I would encourage you to look at this as an opportunity to improve your organization and your code base. All of the reasons listed for why you can or don't want to migrate are actually signals of existing problems in your engineering culture instead. So one reason that people resist moving is their code base is because they have a monolith. Bits of spaghetti code all tangled together. This lack of modularity is really hard to test, and it's really hard to change. And leaving it as a big, huge, tangled ball of code isn't actually going to make your life better. So every day you live with that debt, it's going to cost you and your product and your organization well-being. Speaking of hard to test, many products also, they have insufficient test coverage. And I don't mean test coverage in the sense of lines of code test coverage. I mean products that know paths that have failed and they know they aren't really covered by any testing pipelines. This makes your engineers uneasy and makes them not want to make changes and deploy those changes to customers since they can't be confident the product is going to continue to work afterwards. So a full test suite is certainly not a requirement to migrate, like we said before, but it does help migrate confidently if you have some tests. One reason you might not be using to convince yourself that you can't move is that you're too far behind. You haven't made small incremental upgrades along the way, and you're now trying to bridge this huge gap between the distant past and the present. It's not uncommon for organizations to acquire what is essentially compounding debt. For many companies, you don't have the luxury of improving your product, so the first thing that can go is some form of engineering excellence. Moments like this one that we are in now is proof that eventually you have to pay that bill, and it's always going to be more expensive when you wait. Finally, most companies don't tend to reward work that's about paying down technical debt. This means your engineers are motivated to build on an unstable, technical debt-ridden platform. The spaghetti code isn't going to get less tangled, your tests aren't going to get better, and your process is slowing down. Prioritizing and rewarding work on technical debt is impactful for your organization, and allows your engineering team to move faster, more confidently, and ultimately deliver a better product to your customers. So these problems have nothing to do with the Python 3 migration, although all of them amplify the difficulties in migrating. We take a hard look at our organizations, we all likely have aspects of a bad engineering culture. We have a lot of Python 2 code at Google. So rather than mechanically migrating to Python 3, look at this as an opportunity to improve your culture and your ways of working so that next time you have to undertake this sort of change to your code base, you should feel empowered and not burdened. Maybe this can help motivate you and your engineers to do work and use it as a way to make your engineering process more like the one you aspire to have. Here's the good news. You are on the right track, just that you're here at all and you're thinking about your migration and you're researching ways to make it happen. It's a huge step in the right direction towards a more sustainable code base and a more sustainable engineering culture. It is not impossible. You have the tools, you have a strategy, and you can bring any Python 2 code base into the future. Thank you. And we're out of time for Q&A, but Chris and I will be hanging out, and you can come up and ask us questions afterwards.
Welcome back to the Next Live Show. Building the cloud for everyone takes everyone to create and embrace a culture that is inclusive and representative of our communities. Here at Next 19 in San Francisco, diversity, equality, and inclusion is part of our DNA. Recently, Forbes magazine recognized our commitment, naming Next as one of the top 3 conferences for women to thrive. Let's check in with Joanna for more on the Inclusion Lounge and the hashtag #IamRemarkable workshops happening here at Next.
Thanks so much, Stephanie. I'm so excited to be here at our Inclusion Lounge because diversity is something that I obviously care a lot about, but more important than just being diverse is making sure that we have multiple perspectives at the table so that we can build really interesting solutions to fun problems. So now we're talking to Taylor, who drives diversity, equity, and inclusion at Next. Hi.
Hi, Joanna.
This lounge is great. You want to tell me some fun facts about it?
Welcome to the Inclusion Lounge. And you know, the purpose of the Inclusion Lounge is to make sure that at Next we're always providing content and experiences to support underrepresented groups and allies to be able to come together, share learnings, collaborate, and build community. So yeah, it's a safe space, and at any time people could drop by, connect with like-minded others, get confidence coaching, and also get headshots. And then in the interim, we also have sessions like I'm Remarkable, which is going on right around our shoulder.
I love that session.
Yeah, and this session is happening a couple times at Next, and it takes us through an exercise of empowerment and learning how to promote ourselves in all the positive ways.
What do you think really makes the Inclusion Lounge stand out, and why should people think about coming here during their day?
Yeah, you know what? It's not even about thinking about it, it's just knowing that it's available, because so much about inclusion is you have to be ready to be in the space.
Yes.
And when you're ready to receive and you're ready to learn from others and become an ally or become an advocate, that's the time to actually visit. And it shouldn't be in an intimidating space, it should be a space where you could feel like you could be welcomed, you can meet like-minded people, and you could actually learn and listen from one another. Our attendees are always sharing with us that whether they're an introvert or an extrovert, they need a place to unwind and step away from the commotion of Next and all the wonderful experiences that are available here. And then they're really able to then go from a collaborative mindset rather than an overwhelmed mindset.
Thank you again for building this space. I really admire it.
Thanks for coming to talk to us about it. And always feel that you could drop by at the Inclusion Lounge, because we all know it's really important at Next to build a cloud for everyone. Thanks, everyone.
Thanks very much, Joanna. I'm excited to have Priyanka Vergadia, a customer engineer at Google Cloud, here with me to show us how to set up service level monitoring in Stackdriver. Hi, Priyanka.
Hi, Stephanie. Thank you for having me.
Thank you. Google has published our practices for managing reliable services at scale in Site Reliability Engineering books and this SRE workbook. one of the main principles of SRE is using service level objectives. Can you show us how developers can do the same?
Yeah, let's dive right in and let me show it through a demo.
Okay, great.
Perfect. So I have this website here that is built to order some stuff, and so I'm going to put something in the cart, and it's an e-commerce website, so it lets you order things and then it places an order. So I have my credit card information in there, and we just placed an order. Now, behind the scenes, there's a lot going on in this particular application. So if we look at what's going on here, this is the service architecture of the application, and it is talking, it has a front end, it has various different services talking to the front end, the checkout, the catalog, the product catalog, the cart service. There's a lot that's going on here. And if you see further, they're pretty much all written in very different languages as well. So there's a lot of complexity behind the scenes that's going on. And this is all done through microservices, as you can see. So it's important to understand that a simple website is set up with different, can be set up with different services in the back end and have different languages that it can be written in, so complexities.
Right, and microservice architectures mean the app itself is broken into many small pieces. And doesn't that make it hard to understand how all the pieces fit together and where to start investigating when there is a problem?
It becomes very hard for the operations team, especially in microservices architecture, to figure out what's going on, which services is up, down, talking to each other. So there's a good tool in Stackdriver monitoring called Topology, where you can actually look at the topology of your different microservices talking to each other. So I have it open here, and when you open the service topology, I can look at a specific service that I'm interested in and then see which other services it is talking to. So it gives me a view. I can click on one and it gives me a view of what's going on and which services it is talking to, which is pretty helpful when you're working in an environment that has so many different services, microservices that it's talking to.
Wow, and this is great because with microservice-based apps, you can clearly see the inter-service dependencies and use that to double-check new code rollouts. Yeah. But let's say you're setting up alerts. Ops staff can burn out a lot of the times from getting notified of all the potential causes of a problem, making it hard to align SREs with customer interests. How can we identify which behaviors really actually matter for that service during service degradation?
Yeah, so there is also another tool within Stackdriver monitoring for services where you can actually set up SLOs and define your SLOs for the services, so operations does not actually get affected by just looking at all the different alerts that can come by. It's actually a practice within our SRE teams where we make sure that our SRE staff is only monitoring alerts that are related to customer issues and front-end customer-related issues, and not every single issue that might be a cause to those issues. So let's see that in the demo as well.
Great.
Yeah. So if we click on services here in the Stackdriver monitoring, let's look at front-end, and when we go do that, you're able to see the service level optimization. So let me click on SLOs. And in SLOs, you obviously see nothing here. So we're going to set one up and say we want to set up for availability. And then there is, we can do it rolling or calendar. I want to say in the month, if we reach 99%, or low availability, then I want to get alerted. That's a good way of saying that you're not going to be alerted for everything, but you still want to be alerted for when we go less than 99%. And then you can also set up a latency alert. So in this case, if we say latency, and I may want to set up differently for different services. For the front end, you could say my pages should load in less than 1,000 milliseconds. Otherwise, I want to be notified. And in this case also, let's say it's 90% our goal, and then we submit that. So these are the two alerts that we just set up for latency and availability. And they are not just thresholds because we are saying this percentile. So it's not going to be chatty and noisy. It's going to be, if this happens, then we really want to get notified because the service is not working fine. So that's a good way of identifying, making sure that you're not burning out your operations staff.
Excellent.
Yeah.
How do you follow those best practices given the resources that you have?
Yeah, so you also have metrics and diagnostics in there. So if you click on metrics, you're able to see the request counts and the response latencies, which will guide you through the request and response. And if you click on diagnostics, that actually takes you to the trace. So now if I want to drill deeper into the 95th percentile, which is probably the one I want to look at because it's not performing very well, then I can click on that and see a specific request, why it was slow, for what reasons, and which requests were actually slow. So in this case, we can see that the checkout service was a little bit slow in send and receive, so we may want to drill deeper into that and find out what's going on there. So the diagnostics tab and the metrics tab are really good friends for troubleshooting.
Great, and at some point, you probably need to dig a little deeper into the service's signals. Let's say maybe you received an SLO alert and there's no obvious upstream cause, or you have a customer complaint outside of an SLO alert that you need to investigate, or maybe you need to see how the new rollout of your code version is going. How do you get a coherent display of all the signals for a specific service?
Yeah, so I think the best thing to do at that point is you got an alert through SLO, you want to look at metrics and diagnostics to kind of figure out what's going on, because metrics and diagnostics are going to be helpful to understand which specific service is not performing well. As you can see in diagnostics, when we drilled deeper into a specific service, we were able to find out that checkout is the culprit, and so we can drill deeper into that. So those metrics and diagnostics would be your great friends in order to find out what's actually going on.
Great. So Stackdriver Service Monitoring gives you a whole new way to view your application architecture, reason about its customer-facing behaviors, and get to the root of any problem that arises. So thank you so much, Priyanka, for showing us how Google is transforming the ops experience of cloud-native and microservice deployments.
Thank you for having me. It was fun.
Time now for our next Dev Bite. If you want to learn how to build amazing apps with Cloud Firestore, check this out.
Let's say you want to build an app. Not just any app, but a serverless, scalable, mobile, syncing, analytical IoT app. If you do a quick Google search, you will get 1.2 billion results on how to do this. So where do you start? My name is Natalie Vase, and I'm a product manager on Cloud Firestore. Today, I want to talk to you about building amazing apps. Specifically, how to build globally scalable apps with Cloud Firestore. If you're starting a new project from scratch and you want to build it yourself, you'll likely have to think about a couple of things. Number one, setting up a database. Number two, creating some kind of API layer on top of it so you can make queries from your clients. And that probably means third, creating an authentication service to make sure users can only access data they're supposed to. And then lastly, making sure your data syncs with your local results, which are probably being stored in a completely separate client database. Now, just make sure it works across multiple platforms and can easily handle things like spotty network connections. Simple, right? As soon as your app goes viral, fingers crossed for you, all of a sudden you have to worry about scaling, high availability, and disaster recovery strategies. And you'll probably need to hire more people to manage it too. Or you can just use Cloud Firestore. Cloud Firestore is a fully managed, serverless, NoSQL document database purpose-built for solving some of the toughest problems of mobile, web, and IoT app development today. In many ways, it's more than a database. It's an entire backend for your apps. To create Firestore, we learned from two other popular databases at Google, Firebase Real-Time Database and Cloud Data Store. Usage patterns have shifted since those architectures were designed some 7 to 10 years ago, respectively. So we took a close look at the developer wish list for each of these to inform the product. You can think of Firestore as the best of both of these worlds. Cloud Firestore handles all the things that you don't want to think about when you're developing a mobile app, so you can really focus on your core business. The first thing to know is that Cloud Firestore is fully supported in the Firebase SDKs. This includes web, iOS, and Android, so you can access data directly from these clients. This works in conjunction with Firebase Auth and security rules, and those things allow you to control who has access to read and modify data on the server. There's that auth layer we mentioned at the beginning. You wouldn't believe how normal it has become for people to look at their apps when there's absolutely no chance of connectivity. A person checks their phone an average of 80 times in a day, so it's becoming increasingly common for people to expect our apps to work offline and across devices. With Cloud Firestore, the client libraries already come with full support for offline mode. The SDK handles conflict resolution on device and syncs up with the server when you reconnect. Because we built Cloud Firestore with a serverless architecture, you don't have to worry about provisioning, capacity planning, scaling, or maintenance. There are servers distributed across the world, just not ones that you have to manage. All of this is taken care of by the system. Scaling is automatic and happens as an online operation. Say goodbye to maintenance windows. On top of that, Cloud Firestore is built for the cloud. That means it's replicated across zones and regions depending on how you choose to configure it. And this year alone, and as part of going generally available, we added 10 new locations to Cloud Firestore. Replication across data centers is really one of those things you want to outsource if you can. It becomes complicated quickly and is a huge overhead for ops teams. With this replication, you get 5 nines SLA for multi-region and a 4 nines SLA for regional deployments. This is one of the highest availability services we offer. All of this lets you focus on your core business and leave the infrastructure to Google Cloud, which is our core business. With over 1 million databases created already, Cloud Firestore has seen a huge diversity of workloads already deployed within our customer base. The unifying themes among these workloads include: number 1, the need for data access even when connectivity lapses. Number 2, scalability for many users across platforms. And number 3, the ability to move quickly from prototype to production. And that's Cloud Firestore, your auto-syncing, auto-scaling database in the cloud. Give it a try and find out why it's the most discussed cloud database on Stack Overflow.
Thanks so much, team. Stay right here for more sessions on all 6 live stream channels. After the sessions, join us for a chat with Security Product Manager Ray Wang about building secure environments with Google Cloud. This is the next live show coming to you from the heart of San Francisco.
Here and now, there's nowhere else. There's nowhere else you wanna be. Right here, right now, here and now. There's nowhere else you wanna be. Right here, right now, here and now. There's nowhere else you wanna be. Right here, right now, here and now. There's nowhere else you wanna be. Right here, right now, here and now. There's nowhere else you wanna be. Right here, right now, here and now. There's nowhere else you wanna be. Right here, right now, here and now. There's nowhere else you wanna be. Right here, right now, here and now. There's nowhere else you wanna be. Right here, right now, here and now. There's nowhere else you wanna be. Right here, right now, here and now. There's nowhere else you wanna be. Right here, right now, here and now. There's nowhere else you wanna be. Right here, right now, here and now. There's nowhere else you wanna be. Right here, right now, here and now. There's nowhere else you wanna be. Right here, right now, here and now. There's nowhere else you wanna be. Right here, right now, here and now. There's nowhere else you wanna be. Right here, right now, here and now. There's nowhere else you wanna be. Right here, right now, here and now. There's nowhere else you wanna be. Right here, right now, here and now. There's nowhere else you wanna be. Right here, right now, here and now. There's nowhere else you wanna be. Right here, right now, here and now. There's nowhere else you wanna be. Right here, right now, here and now.
Please welcome Ruslan Kusov.
Hi. Hi, guys. I'm really happy to see all of you here today, and I suppose that my session, my knowledge will be really interesting and useful for you. And today, I would like to talk about infrastructure as code and infrastructure as code with Deployment Manager. A few words about myself. I'm Ruslan Kusov. I work as a DevOps architect for SoftServe. I have about 9 years, almost 10 years of experience in IT. I started as a system administrator, network engineer, SRE engineer, and now I'm DevOps architect. And I'm also the Google Cloud Professional Certified Architect. And I think that I have enough practice and experience in all that stuff and can really help you with your problems. Okay, so what are we going to discuss today? We are going to start with from scratch, actually, from cloud journey inception. We will talk about how to become cloud native. What should we do for that? Why does infrastructure as code matter if we talk about cloud native solutions? Next, we'll do intro into Google Cloud Deployment Manager. It's a really cool service from Google, and I will tell you why. At the end, I'll show you a short demo about CI/CD integration with Deployment Manager, and at the end, supposed to have some conclusions and the questions from audience. And I would like to start with a question to you. So, do we have any people who tightly works with cloud? Any cloud? Any cloud? Oh, okay. Google Cloud in particular. Yeah, who? Oh, okay. So you are pretty familiar with that. And just last question. Who do you really think that he or she do everything in the right way? Okay, so we still have self-confident people here. That's great. I can tell that you can be sure in this that you actually do everything in the right way, because Google continuously introduce new services, continuously provide you with new features. You have your own new experience. You have experience from your coworkers. You have experience from other companies. You visit a lot of conferences, and you understand that sometimes you do things in a way that's more applicable for you, and there is no actually the right way. And that's the main problem that we have about cloud journey and cloud journey migration. So when we start talking with our customers about cloud, they actually scared. They scared about cloud not because of cloud itself, but because of changes. Because they understand that in case of migration to the clouds, these changes will be significant. And they do not know how to operate with that cloud, how to operate with cloud APIs and so on. And at the end, at the beginning, actually, of this migration, you have a lot of questions. And before you start, you have this moment of clarity, yeah? You have questions, are we ready to go to the clouds? Should we worry about cloud migration? Are we aware of all potential risk of this migration? What cloud model should we choose? What service model should we choose? And a lot of questions, actually. And you should scared about cloud migration. You shouldn't scared about cloud migration, but you're scared because you understand that you should change the way how you work with infrastructure. So on the one hand, we have all the benefits that can be provided with clouds, like uptime, like managed services, like shared responsibility model, like cool features and stuff that available into the clouds. On the other hand, you still have all that fears. And I would reference to Google Cloud's migration journey and migration journey model, and it looks like baseball. So you have 3 bases, you have home plate, and you should do a home run or you will be tagged and out of game. So you should pass through all that bases and achieve final result. You can see that you should start with proper assessment, continuous with planning and testing, perform migration, and at the end you have validation phase and confirmation. And that's the last phase is continuous. So you continuously improve your cloud. And that's why I'm pretty sure that even that people who answered that they are pretty familiar with cloud and do everything in the right way, they don't, because they still have a lot of chance, a lot of things to improve. Oh yeah, that's about my life actually. I started, as I mentioned, as a system administrator, and I think that it's like a great example, and this example can be extended from physical world to the cloud, actually, yeah? So I started as a system administrator, and I had a task from my team just to migrate all the equipment from all our offices to one server room. And I did this in that way, and that was wrong, because if I had been married on that time, I would definitely have gotten divorced, because, you know, I spent about whole my days, 24/7, I spent to fix all the issues that I had there in that data center. I did this without gathering all the requirements. I did this without checklist. I did this like simple lift and shift, and I have no plans for optimization. And that's the right way. So when you start with assessment, when you plan all the migration phases, build landing pods. It's important part of any cloud. Start with landing pods, so prepare all things that is required to start your migration. Run MVP, and finally optimize that solution. And with this actually approach, you'll have nights with a proper sleep. And to summarize everything, we can actually switch to the next question. Why does infrastructure as code really matter? So just imagine that were examples about physical devices, about servers itself, but what about virtual machines? So do they still have the same problems for the migration or not? Yes, they do. So, okay, you're ready to go to the cloud, you have your virtual machines, and you think that everything should be fine. So you just take your virtual machines from your data center, move to the cloud, and leave as it is. Okay, but it's not true. What about this infrastructure? It's still the same virtual machines, but you decided to take some advantages of Google Cloud. You decided to take that advantages actually by building auto-scaling group for your machines, because you want higher SLA, you want be better, you want your customer be satisfied with your solution. You decided to use cloud storage for that, just to store some kind of state data, some photos, some static files, and other materials. Also, you should create VPC, because without VPC, you cannot launch any virtual machines. Of course, you have default VPC, but it's not a proper way, especially if you are going to build several environments and to do VPC peering or do VPN to your on-premises data center. You will have a problem in the final end. And you should build a proper VPC with proper SIDR range, with subnets, and you should configure cloud firewall rules. You should configure cloud DNS records and a lot of other stuff. And you should configure cloud routing, or routing, it depends where you're from, but anyway, you should do all that stuff. And that's just for simple migration of your virtual machine to the cloud. What about that infrastructure? That's actually one of the real cases. So we have virtual machines, we have BigQuery, we have Kubernetes cluster here, and we have a proper organization structure. So with several projects, project per environment. So you should, before promote to production, you definitely ought to test your changes, your code somewhere. So you have dev environments, you have the stage environment like pre-production. You have CI/CD environment where you launch all stuff related to CI/CD, like Jenkins, like source repo, and so on. You have container registry in that account as well. So all that stuff, and you should build all the environments in a reproducible way. And if you do everything manually without any kind of infrastructure as a code, you will fail. Why? Because you actually cannot guarantee that you will repeat yourself on each environment with manual configuration. Because, for example, I started today, I did some kind of changes, I launched a virtual machine, and I assign its IP address to that machine, and that's it. And my coworker for the next day should reproduce this on production environment. And for example, he forgot to configure firewall rules for that machine. And that was a real case for me. So I spent about several nights after release trying to figure out what's going on with the environment. Everything should work, but no. And that was the issue with firewall rules. So that's the main problem of manual changes. And we have pets and cattle models. So we cannot treat with your environment in the clouds like you did this before with your on-premises data center. And these two pictures clearly illustrate this. So on the first picture, we have the cats. This is the real cat of friends of mine. And this cat, his name is Tima. It's like Ukrainian for Tom. He's pretty happy here. Yeah, he has a fancy dress and he has a New Year party here. You know, I just realized that even I didn't have either New Year's party or a fancy dress, but this cat had, yeah. And she cares about this cat. She cares when he is ill. She, I don't know, she put him, she just loved him, and that's it. And he is a member of family. The same with your virtual machines in your on-premises data center. So you cares about that virtual machines. You care about each server. You know how it's named. Like, I don't know, like Jupiter, or it can be some kind of strawberry, raspberry, or something like that. So we named our servers in our own data centers, but not in clouds. In the cloud, you have the picture number 2. So you have a cattle concept. So that's cow, but you have SLA with your customers, how many milk you will provide to that customers at the end of the day. This is SLA for that service, for that cows. And you don't care when someone from this cow is dead or is ill, yeah. What's the reason for that? You still have this determined SLA, and you should operate with your cloud virtual machines in this way, following this cattle concept. You shouldn't care about how many virtual machines launched, how many containers. You should be focused only on service, on SLA, service level agreement with your customers. And what do we have here? We have actually 4 pillars for infrastructure as code concept. And the first one is avoid human error. So you should do everything in a predictable way. No manual changes. Automate all your infrastructure. Automate code validation. Do not repeat yourself in your code just to avoid, again, this human error. You should automate all repeated tasks because you do this day from day, and you will continuously do this in the future. And you should automate this type of tasks. You should follow all the cloud security practices because it's highly important. In clouds, we have a lot of questions about security in the clouds, about who is responsible for which part, and so on. And you can do this with infrastructure as a code. And finally, you should allow actually agility and flexibility for your environment. OK, so Google Cloud Deployment Manager, this tool is actually the great tool probably to start with in a Google Cloud when we talk about infrastructure as a code. Especially for me, I started with Terraform, but I think that I was prepared for that. I had a lot of experience with code writing, with configuration management, and so on, and Terraform wasn't so difficult for me. But for the beginners, you definitely should start with Google Cloud Deployment Manager because it has clear concepts, and I will show you a little bit later. So, Google Cloud Deployment Manager, according to Google documentation, is an infrastructure deployment service that automates the creation and management of Google Cloud Platform resources for you. What are the key points of Deployment Manager? First of all, it's repeatable deployment. So it's like principles of idempotent principles. Yeah. So you should launch some piece of code, yeah, and at the end, with a 100% guarantee, you'll receive predictable result, the same result for each code launching. Next is template-driven. So you create templates for this code, and you reproduce the same templates through all the environments, and you have consistent environments for starting from test and finishing with production. Declarative language. So what does it mean? You just create description for your final infrastructure that you are going to achieve, and Deployment Manager will decide it for you how to achieve that final infrastructure, and do this in a proper way with proper dependencies and so on. And finally, you will be focused on your application, only on your application code, not on infrastructure, because you will be sure that everything will work fine in infrastructure, in the same infrastructure for each environment. What about features? We have a lot of features that can be provided with Deployment Manager. The first one is actually parallel deployment. So you can launch deployments, and it will do several deployments in parallel time, actually, simultaneously. Deployment Manager, as I mentioned, has templates and schema files. Schema files is another great feature. So it's like some additional components for templates that allows you to describe how to use that template and just define some default variables and protects customers from some unexpected usage of that template. Next is updates. So you can do updates with your deployment manager, but you should be careful about about the way of doing this, because for some resources, again, following the principles of immutable infrastructure, you cannot just update that resource. You should recreate that resource. And this is done on purpose because you should avoid any kind of configuration drift at the end, and be careful about that feature. Next one is inputs and outputs parameters. So you can use any kind of inputs and determine as variables, and use outputs for another models and create a proper structure with dependencies like nested template structure, and reuse outputs from previous deployments to next deployments. Type providers, another cool feature of Deployment Manager. With type provider, you can actually choose any kind of API that has a proper description and meets the requirements, and integrate with Cloud Deployment Manager. So for example, if Cloud Deployment Manager cannot manage Kubernetes, but Kubernetes has this API that allows you to do this, you can integrate Kubernetes API to Deployment Manager with type provider. This feature is in beta, but anyway, you can try and use it. It's cool. References. Again, to allow dependencies between models, between configurations, between templates, actually, you can use these references. Preview mode. This important feature, especially for CI/CD pipeline, when you are going to launch and review what changes will be promoted to the environments. And that's why you definitely need this preview mode. It's like some kind of dry run. So you just run preview, verify that everything is OK and you agree with that changes, and after that, run updates, and this deployment will be updated or promoted to the environments from scratch. And console UI, it's a feature for fancy users, but OK, let's leave it there like a feature. That's pretty simple commands that probably you will use with the deployment manager. So as I mentioned, it's creates, updates, cancel preview, describe, deletes, and preview mode as well. What about fundamentals? So with deployment manager, we have, first of all, configuration. So it's a set of resources that will be deployed to your environment. Resources itself. So it's like virtual machines, IP addresses, VPC, and other kind of Google Cloud resources. Resource contains name, like virtual machine or any other kind of name. Type, again, it's compute virtual machine, compute v1 instance you can see here. It contains properties. It's a set of parameters that can be provided to that machine, like boot storage, like source image, and so on. It contains also types. Yes, I mentioned about types. Yeah, OK. Another fundamental thing of deployment manager is templates. It can be Jinja 2 or Python templates. It's up to you, but I would recommend to start with Jinja 2 because Python is a little bit complicated, and with Jinja 2 you still have that YAML format, and you still have that kind of declarative format for the promotion. With Python, you should write your own code. And OK, yeah, it has more features, but still it's more complicated for the beginners. And manifest. Manifest you can review with a web UI, for example, and understand what's going on in case of any errors during deployment. And deployment itself, so it's set of configuration, it's a set of resources that will be deployed by that configuration. As I mentioned about Jinja templates, you have some features related to this. You have environment variables, you have loops, you have conditions. So again, comparing with Terraform, with another tool, we know that in Terraform, they introduced it actually for the Terraform 0.12 version that they will support loops and conditions. But for now, they are in beta, and that's why you have that benefits. You have that, yeah, it's benefits comparing to Terraform, to use Deployment Manager, to have all that feature in your stack right now. Wow, next I would like to tell about directory and file structure. So this is a directory and file structure that we can propose for the beginners. Again, if you don't want to use Python, if you don't want to overcomplicate your environments, you should start with Jinja 2 templates, and probably you'll have the same directory structure. And I will show you how it works in demo. But right now, I would like to say that what can we hear? What can we see here? So we can see that we have root directory with deployments. We see several subdirectories. Each of that directory contains Jinja templates, contains schema files, and contains configuration YAML files divided by environments. So for example, in production environments, we have variables related to production environments, properties related to production environments. In stage, we have the same for stage environments. And when we launch this in our CI/CD pipeline, we just apply changes for production or for stage using either prod or stage file. And in a root directory, we also have a changelog file. Jenkins file can be skipped. It's only for Jenkins for this demo. README file and version. Why these files are important? So in version, you store the version of these deployments that is applied to your environments, and I will show in my demo how you can operate with that version and why it's so important for you. In changelog, you have all the changes because, for example, when you have security audit, when you have PCI DSS compliant product, and you have QSA that has his own questions about your environments, you can show him this changelog and tell that, you see, all the changes were done according to this changelog, according to these Jira tickets or any other type of requests. And we have version file that's supported, and we can switch version to version just to show you that everything is OK. And with version file, we can create a tag for our branch in Git repository and do a proper rollback in case of any issues with our environments, and we really need that rollback. OK, so CI/CD for Deployment Manager. Is it possible? Yes, it's possible, actually. That's a quick answer for my question. So what is CI/CD? CI, you are pretty familiar with that. We have continuous integration, and the end of the continuous integration is artifact stored somewhere in the registry, in the Artifactory. For Deployment Manager, we can have the same. So we can have a code repository. We can have code review procedures with at least 2 reviewers who will review all the changes. After that, the changes can be merged to production and launched in front of sandbox environments in Google Cloud. And what you will achieve after that? You will achieve, first of all, with the preview mode, you can control all the changes that will be provided to your environments. And also, you can track, you can launch actually tests, integration tests in front of that environment. For example, in our cases, we use Inspect framework for that with the GCP integration. So we just describe tests and launch that test in front of that sandbox environment during CI part of the pipeline. What about continuous delivery and continuous deployment? So with continuous delivery, we still have someone who should push the button, who should approve our promotion to the production environment. With continuous deployment, we don't have this person. But with continuous deployment, we should guarantee that everything is OK. Everything should be covered with tests. So inspect is a must here. Security testing is a must here as well. You can create your own security test writing on Go language or Python language and run the test in scope of this pipeline to test your infrastructure for security issues, or you can use some third-party solutions for that. So it means that infrastructure as a code, it's not only about automation. It's also about source control, versioning, audit trail for all changes, as I mentioned, testing and verification, collaboration for infrastructure management. So now this is not one person who do all that stuff. So we have several people who manage that, and you can track and control all the changes. And you have documentation. Documentation is an important part because documentation in a classic formats in a conference or in some doc files, it can be outdated, but code will never be outdated. It will ever be up to date. So that's a great feature as well. OK, so what about demo? And I have, for the demo, can we switch, please, to my demo machine? Oh, yeah, that's great. So for my demo, I decided to show you how it looks in Jenkins. So we have a Jenkins pipeline for that code that I showed you previously. And I already launched this pipeline, and I have some results. So let's verify what do we have. So first of all, we have several projects. One project is for CI/CD. So in this CI/CD project, I have my Jenkins managed by deployment manager as well. I have stage environment, and I have production environment. And this environment is separated by projects. What about code? OK, let's close these extra files for now. I have, as I mentioned, yep, just a moment, please. Yeah, that's great. So I have this directory structure. So I have VPC-related deployments and templates and configuration, instance group, and changelog, README file, and version file. So in this demo, I'm going to deploy VPC with the proper firewall rules, with proper subnetwork, and launch managed instance group in that VPC. And on that managed instance group, let's see on instance template, I have some simple site, my biography, and let's see how it looks like after the first deployment. OK. OK. That's awful. I think that you shouldn't have seen this, actually, because after this demo, I have no chance to be promoted to HTML designer position. OK, let's do something with that. So you can see that I have information about myself, and I have version that's actually provided by property from my deployment and provided by that version file. And I have environments. So I have this for stage environments, and I have for production environment as well. So let's make some changes to this code. I will cheat, if you don't mind. I have some helper for that changes. Yep. So first of all, I would like to update my photo because it's out of date. I'm young and happy there. Note about my current state. OK, and do some updates with the color. So let's start with this part, and yeah, with the body color as well. So yeah, OK. What should I do next? First of all, I should update version. Now it's version 1.18, and again, I follow like semantic versioning, so I do some kind of patches here, so that's why I update patch version. And I should update changelog file. So in changelog file, I track all my changes according to tickets that I have, for example, in Jira. So let's pretend that I have Jira here. Yeah. 1.18 version, and ticket number 19. OK, updated index.html page. Yeah, that's correct. That's all the changes that I did here. OK. Let's commit these changes. Don't do this in your real life, because I will commit to master branch. Yeah, OK. We are on the same page. It's great. OK. What about message for this commits? Yep. And git push. Yeah, we are done. OK. What do we have here? So for this demo, we used cloud source repository, and a new feature related to this cloud source repository announced recently is SSH support. So previously, cloud source repository supported only IAM. So IAM policies can be integrated, and you can use this repository only with the gcloud. But now you can use in a pretty familiar way, like you use any kind of other Git repositories with SSH key. So you just can import this SSH key and use in a pretty familiar way. But anyway, this feature is still in beta, so it means that it will be updated, definitely will be updated, added probably code review, because it is missed right now. We don't have code review. But I think that this feature must be here, because it's quite important to have that code review model, to have a whole pipeline tools in your in scope of GCP environment. Okay, so what do we have with our Jenkins? Yeah, you see that we have webhook launched, and we have a pipeline. Let's see console log. So this is our pipeline. You see all that steps. So first of all, we update VPC, next instance group, and wait for user response to promote to production. So I have continuous delivery here. Unfortunately, I have no inspect test in this pipeline, because, as I mentioned, inspect test makes sense to do in front of sandbox account, and we have not enough time for that. Sorry. So. But if you wish, you can ping me, drop me a line in LinkedIn, and I will show you this like in a during brief call. So it's okay. Yeah, let's see console log. So what do we have here? As you see, we have first of all review. So it's some kind of preview mode, dry run, and after this preview mode, you can see what resources will be updated and what version will be provided to these resources. And here is updates for our stage environment, and we have completed updates for all resources. And you can see that we have outputs here. So in outputs, we have a front-end IP address provided from our load balancer. As I mentioned, you can use outputs in your deployments, in your templates, and reuse this output for your particular cases. Yeah. So what do we have right now? We are waiting for response. Promote to production. Yeah, let's promote this to production. Okay, so we have this updates on stage. Let's wait. Yeah, it takes some time, because we just relaunched our instance. So as I mentioned earlier, for some resources we cannot launch properly update, because it means that at the end we'll receive configuration drift. And to avoid this and to follow immutable infrastructure principles, we should recreate that resources, like in this case. So we just recreated resources in instance group, launched new, and terminated the old one. Yeah, let's wait for updated sites. And meanwhile, let's see for our pipeline. Yeah, we are waiting for production updates and for finalizing this pipeline. Yeah, just a moment. Let's see what will happen here. Oh, yeah, by the way, while we're waiting, I will show you that we have tags, and the last tag is 0.1.17. So I suppose to have 0.1.18 tag after release to production environment. So as I mentioned, using that tag, we can roll back to the previous version in case of any issues on our environments. Okay, site cannot be reached. Let's wait why. Okay, just a moment, please. Yeah, first of all, yeah, we have success pipeline. We have success, yeah, and we have a new tag, as I mentioned, 0.1.18. Okay, let's see that tag. Let's update our cloud source repository. Yeah, you can see this tag. So switching to that text, you can check all the changes promoted to the environments, and you can actually roll back to the previous version. Another cool feature that we have all the changes mirrored in admin audit logs, so it means that that logs can be used to track all the activities with your environment and avoid any kind of unexpected changes from someone except deployment manager. So you can trigger and you can launch any kind of notification for any problems with the API calls for your environment. So again, it's reasonable from security points of view, so you can guarantee that only deployment manager and only Jenkins user can perform any updates to your environment, and that's cool. Yep, now it's better. And we have some colors here. We have updated photo. This is me awarded as the best DevOps engineer in the UK last year. I'm happy here, and I'm done. OK, and you see that we have updated version 0.1.18, and probably we'll have the same for production. Yeah, let's wait for production. Yeah, and you see that this production environment. So can we get back to our slides, please? Oh, yeah. Let me draw some conclusion about that, summarize everything that we have. So, first of all, plan your infrastructure, plan this in a proper way, because without that, you will have no family, no wife, you will sleep at your work. That's true. Test cloud infrastructure like software. So, again, you can create code for your infrastructure. You can actually do everything that you do with the application code repo with a cloud infrastructure repo. Start your GCP journey with Deployment Manager. As I mentioned, it's a more confident and easier way to start than Terraform, and it has a lot of benefits like loops for Jinja templates, like if conditions and so on, and like type providers that allows you to integrate any other APIs to your deployment manager. Next, follow all deployment manager best practices. Google actually has a lot of documentation related to deployment manager, so just review all that documentation. If you have any questions, you can ask us. We, as a SoftServe team, will provide you with our own best practices. We had a lot of headache, and we shuttered our legs on our journey to the cloud, and we know how to treat with that, how to handle that. What next? Remember to plan scalability. So remember that your infrastructure will not be finalized on that, as you remember that picture with my server room, on that one stage with the one server. You will be grown, and it means that you should be scalable. Automate the creation of project and resources. Yeah, by the way, with the Cloud Deployment Manager, you can not only automate infrastructure resources creation, but you can also automate project creation. So any type of IAM entities, projects can be created with Deployment Manager as well. And remember about CI/CD for Deployment Manager. It's highly important. Okay, guys, your feedback is greatly appreciated. Please complete session survey in a mobile app. I use Next Resources for this. So first of all, it's Google official documentation, and also Last Resources is highly recommended for you because this is a GitHub repository with samples, with deployment manager samples created and managed by Google. So it's really useful, especially for newbies like we were, and for professional guys as well. And thank you for attending this session. We are SoftServe team. We will glad to see you at our booth number 1453. So please join us, ask your questions, and contact me via LinkedIn, email. I'm happy to answer to all your questions. Thank you very much.
Welcome back to the next live show. I'm Redo Maya.
And I'm Stephanie Wong. Joining us now, Ray Wang, Security Product Manager for Google Cloud. Thanks so much for joining us.
Thank you, it's great to be here.
So security is such a vital part of everything we do online and in the cloud. Let's talk about security at scale. As our environments grow larger, security simply must keep up. How is network security changing as we move from brittle environments built on static IPs to microservices?
Yeah, the traditional IP-based networking policies require to have very detailed knowledge on the nitty-gritty parts of your networking configurations. They don't really offer you a concept of which service can talk to what unless you segregate them by IP addresses and subnets ahead of time. And this quickly becomes unwieldy, right, as you scale your infrastructure, especially as you introduce the concept of microservices. And this is where a cloud-native platform like Istio or the managed version CSM give a very different kind of experience. They allow the admins to define high-level policies that focus on application requirements or business logic. The microservices are backed by namespaces, which give you natural isolation boundaries, and each service is also given a unique Istio service identity. Then you can set policies leveraging these identities and boundaries. For example, you can set it to be zero trust by default between the services so that any communication will require explicit policies, and then mutual TLS is enforced by default. And once you have configured your policies, CSM can allow you to centrally manage and monitor and control service-to-service traffic and alert on any policy violation. So this is how, with a microservice-focused platform like CSM, it's much simpler to both create and do ongoing monitoring of your network security policies.
Okay. And so how does moving into a hybrid cloud environment impact security?
Yeah, so moving to hybrid environment, especially with a product like Anthos, right, means you now have a consistent control plane between on-prem and cloud. It gives you a single admin experience in a single pane of glass, which makes it much simpler to have central visibility and control across your hybrid deployments. And then you can also start using some of the Google security capabilities even for your on-prem workloads. For example, products like binary authorization or Anthos config management now work for on-prem as well. And of course, another benefit of using a hybrid platform is that it helps your workloads to get cloud ready, right? Because containers are portable and the admin experience is the same. So when it comes to time to migrate, it's a very straightforward process. And then of course, once your workloads migrate to cloud, we can offer you additional security values, things like shielded VMs or zero downtime patching through live migration, even when there are really big hardware vulnerabilities like Spectre and Meltdown.
You mentioned security consistency. Yeah. What are some of the best practices to ensure a security baseline with consistency and reproducibility for all of your resources in the cloud?
Great question. We know that security is kind of shared responsibility, right? We do our part and the customers do their parts. So in the platform, we offer a lot of security capabilities so that customers can start on a much higher baseline. But at the same time, we also make sure that we also want to make sure your part of responsibility becomes easy as well, and that's often done through templatized deployments, central config and policy management, and ongoing monitoring and alerting. So then in terms of deployments, by using Kubernetes-style API, you can express your configurations as declarative templates. Then Anthos config management give you a central source of truth for these templates and allow you to deploy the config and policy updates by GitOps and CI/CD best practice. These changes then get deployed to across all of your clusters and meshes in the environment to ensure consistency. And then when it comes to constraints, there are a couple of frameworks, Gatekeeper, Policy Controller, and Forseti config validators that we're actually developing in the open source with communities. They allow admins to standardize configurations across your entire organization. You can, for example, set guardrails by pre-submit checks in your release pipeline so that misconfiguration can't even get into the deployment process. And then in case drifts happen in production, you can also set alerts so they can get notified. For monitoring, we also have Cloud Asset Inventory and Cloud Security Command Center. They give you a central view of the state of all of your resources in production, and then can notify you of changes and risks and security findings and so on. So together, these tools help you through the life cycle of managing your security config settings.
Fantastic. Can you talk a little bit about declarative configs to make security controls consistent across sort of scaled, diverse environments?
Yeah, so we all know one of the most costly mistakes an admin can make is misconfiguration. Right, it's almost far too easy to accidentally set your IAM controls to be public, or make your network configuration to be way too permissive. And when you do that, you open up your sensitive resource to attacks and data leaks. So this is where declarative config makes a difference, because it helps the admin to focus on the end goal, the end state, and then allow you to offload the intermediate orchestration and workflows and keeping of consistencies really to the platform. And then when we do that across a lot of resources, across many clusters and meshes, we basically achieve reproducibility and recovery from drift, and therefore they reduce the complexity of applying security controls. And they also make it much easier to share security best practices because you can deploy templatized solutions.
And not only is it important to declare your security configs across your environments, but also monitor inevitable risks. So we have a big launch, as you mentioned, Cloud Security Command Center. How do we help customers get visibility into risk in their environments?
Yeah, we're very excited about Cloud Security Command Center because it kind of unifies the security detections from Google, right, together with a lot of the key third-party detections, put them in a central place, and really help the admins to view them, analyze them, and take actions in place. For example, one of the capabilities is security health analytics. Right? It scans and detects over 20 common vulnerabilities, from publicly exposed storage buckets to, we talk about overly permissive firewall rules, to misconfigured Kubernetes clusters and so on. And then similarly, you have cloud anomaly detection. It automatically detects some of the key threats from cryptojacking to exposed service account credentials to outbound DDoS. And then with this GA release, another benefit you get is now Cloud SCC unifies security findings from a variety of Google Cloud products, from advanced threat detection to binary authorization to cloud asset inventory to AXT and so on. How you can use it? Well, if you're an enterprise company, right, and you have a finance department, for example, that stores credit card information and sensitive personal data, you can use Cloud SCC to scan the infrastructure used for storing the sensitive information, identifying vulnerabilities, as well as finding active threats that are targeting these vulnerabilities. And then that's a lot of findings, so we give you a way to manage and organize these findings by attaching business context to the findings and the resources via ACL security marks. And then we all know that getting the data is the first step, right? What you really want to do is to improve your security posture from the data. So Cloud SCC also allows you to actually respond and take actions by, for example, triggering alerts or creating IRM incidents or directly executing remediation operations by Cloud Functions.
Great. Thanks, Ray. Your insights into security will continue to be vital to any company that wants to build and grow quickly.
Thank you.
Now, over the last 3 days, we've brought you amazing demos from our showcase. But guess what? There is so much more. Here are Natalie and Mark to take us on a tour.
Welcome to the Google Cloud Next 2019 showcase floor.
We're super excited to take you around all the different demo areas and neighborhoods that we have around the floor.
There's lots of cool stuff down there, so why don't we show you around? There's so much great stuff here at Google Cloud Next 2019. We've only begun to scratch the surface with the showcases we've shown you, and there's tons of people here with high energy.
I know, right? I think there's roughly around 30,000 people or more here, actually.
Amazing.
Lots of amazing demo stations where you can learn about our Google Cloud platform.
Yeah, it's super cool, but if you weren't able to see it for yourself, don't forget to check out all the content on YouTube so you can see us showcase some of these demos, but also see some great talks.
That's right, and we're looking forward to seeing you next time.
Thanks very much, Natalie and Mark, for those highlights. Now, we want to share a fun competition that happened here at Next. Earlier this week, in our DevZone Theatre, we got to see how heroes are made in the cloud.
Cloud Hero is a hackathon where players test their knowledge of Google Cloud through timed challenges. The challenge is built on an entirely serverless system using Angular, Cloud Firestore, and Cloud Functions. Thank you to all our participants, both here at Next as well as online.
All right, it's time to step away for the next session. And afterwards, Stephanie and I will be back to wrap things up here from Next 19.
you. I'm going to ask right after.
Hey, everyone. Welcome to this data and analytics session on GCP, or GCP for Kafka users. My name is Karthi Thiagarajan. I'm a solutions architect with Google Cloud, focusing on big data.
Hey, I'm Ricardo Ferreira. I'm a developer advocate for cloud stuff from Confluent. Glad to be here.
Yeah, this is awesome. I had no idea there were so many Kafka enthusiasts at this conference. So I'm going to do a quick survey before I get going. How many of the people in the room are GCP users who are new to Kafka? Wow, I'd say about 10%. Ricardo?
All right, so let's make a simple question. How many of you have heard about it or actually using Kafka somehow? That is great.
Oh, wow.
Beautiful.
Okay.
You're in the right place. All right, so cool.
Last session of the day. All the Kafka enthusiasts are here.
Yep.
Awesome, cool. So this is a demo-heavy session. Hopefully that's good. But before we get into the demos, we want to do a little bit of context setting. First thing I want to talk about is where all of this, Kafka, GCP stuff fits in into a kind of a prototypical architecture. I'm sure you've seen this kind of a stream analytics architecture before. Another thing I want to mention actually before I dive into this is not a session on stream analytics per se. Obviously, because it's Kafka, we're going to talk about stream analytics quite a bit. There is another session for those of you who have missed it. It's DA 311. It's stream analytics or advanced stream analytics on GCP. Strongly encourage you to watch that recording if you haven't, attended that session. There's another session, DA 304. I believe that was on Tuesday, and that's also about stream analytics in real life. It talks about PubSub, not Kafka focused. So definitely recommend you watching the recordings of both of those sessions. With that said, let's get into this architecture here. So obviously there's ingest, right? We're talking about streaming analytics. We have to ingest data somehow. The Kafka people know about Kafka. For people who are new to GCP, there's something called Cloud PubSub. It's a similar service to Kafka. There are some significant differences, but in a lot of ways, it's optimized for doing stream analytics. And then when you need to process your streaming messages, you have a number of options as well. In the Kafka universe, there's KSQL, Kafka Streams, and a bunch of others that Ricardo's going to do demos on. In the GCP world, the thing that we're going to focus on in this session is Apache Beam with Cloud Dataflow. How many people have heard about Beam and/or Dataflow? Wow, more people than have heard of GCP. That's good. And then once you've done these transformations and/or processed this data, you can then write that to a variety of so-called sinks. You can write it to a data warehouse like BigQuery on GCP. You can do real-time predictions with Cloud Machine Learning Engine, or you could write it to a time series database like Cloud Bigtable. I want to look at this diagram through a slightly different lens. The main thing I want to call out here, we've talked about ingest and processing. There's also an important piece when we talk about stream processing, and that is this idea of connectors. Stream processing would be a lot more challenging if you had to write custom code to do, to pull data from all the sources that you need to read from, like MySQL, Postgres, GCS, et cetera, and then on the other side, if you had to write custom code to sync data into all these sinks. So out of the box, with Kafka Connect, you get a variety of these connectors in the Kafka world. On the GCP side, there are these Apache Beam I/O connectors as well. Between the Google-provided connectors and the community-provided connectors, you typically shouldn't have to write your own sources and sinks. This makes your job a whole lot easier, and we're going to be using one of those connectors in our demo today. I'll also quickly mention that you can use the Hadoop ecosystem of both processing tools and connectors, with Cloud Dataproc. This is our managed Hadoop service on GCP. We're not going to be spending a lot of time talking about that today, though. Even though there are quite a few people that know about Beam, I want to spend a little bit of time kind of level setting on what Beam is and what Dataflow is. So Beam is, or Apache Beam, I should say, is essentially an open source SDK that lets you write code in Python, Java. Now we have Go support, and we also now have SQL support, which is really awesome because when you can do SQL against streaming data, it makes it a whole lot simpler to kind of reason about it and actually focus on your application logic. And then Beam has a variety of runners that you can actually run your Beam code against. One of those runners is Cloud Dataflow, which is native to GCP. But you don't have to limit yourself to that runner. You can also use Apache Flink, Spark, IBM Streams, etc. So that's kind of the key distinction, I guess, or the thing to keep in mind between Beam and Dataflow. I sometimes use these two terms interchangeably, but just keep in mind that Dataflow is the runner and Beam is the programming model. All right, now I'm going to hand it over to Ricardo to get into Confluent Cloud.
All right, thanks, Carly. I'm going to spend a little bit of time explaining what Confluent Cloud is. We're going to have a lot of, I think, a series of 3 demos, right?
Right.
Confluent Cloud.
Right. Lots of demos.
And yeah, the talk part is going to be only this part. I mean, after this, we're going to go straight to the code, and it's going to be fun. All right. Confluent Cloud is actually the result of the combination of Apache Kafka, and we've actually released this service a couple years ago. And the primary objective of this service is to make available Kafka as a managed service. So in other words, you don't have to, as a developer, as administrator, to manage, install, patch, upgrade by yourself, and you use it as a service in whatever cloud provider you want to choose, whether it's GCP, AWS, or Azure, right? Some of you might have heard this week that we straightened our partnership with Google Cloud. And as a result of this, we are bringing Confluent Cloud as a first-class citizen for GCP. What that means for you is you're going to be able to spin up Kafka clusters straight from GCP console or GCP CLI, G-Cloud, right? As well as instead of having 2 subscriptions and 2 billing modules, you're going to have to use your own credits from GCP and spin up your clusters, and that's it. You don't have to pay extra money for Confluent and all of that, right? By the way, how many of you know what Confluent is? You make me very happy by raising your hand, sir. Thank you. All right, so Confluent, for some of you that don't know what Confluent is, it's a company that was founded by the original creators of Kafka. So long story short, Kafka has been created on LinkedIn plus 10 years ago, and the original creators kind of left LinkedIn and built their own company. They call it Confluent, right? And we've been spending a lot of time kind of managing Kafka at scale for the last 5 years. And Confluent Cloud is the result of this expertise that we built in Confluent. I mean, we became pretty good at managing Kafka at scale, so we created this service for you, so you as a developer don't have to worry about how to install Kafka. I mean, if you think about it, Kafka has been around for what? Plus 10 years, right? It's been created 2007, I think, and open sources to Apache in 2008. So it's definitely not a new technology. So why don't you have to worry about the cluster itself? What you have to worry about as a developer is building applications and connect to clusters, right? Just like you would do with a database, right? Redis or SQL databases, NoSQL databases, etc., right? All right. So on top of a managed Kafka service, what also Confluent provides is a set of resources and technologies and built-in implementations that we've been developing for the last 5 years, and that's the value that we also get with Confluent Cloud. So if you are a Kafka developer, you know that for implementing an end-to-end stream process data analytics, you have to use a lot of other implementations. Sometimes you have to sit down and write the code yourself, whether it is for connectors, whether it is for your consumers, whether it is for managing Kafka properly. So as part of the Confluent Cloud subscription, you also get access to a bunch of other stuff that makes Confluent Cloud not only another managed Kafka service, but also actually an end-to-end complete solution for building stream analytics on top of Apache Kafka. So 3 main examples: clients. Whether if you are developing Java, C++, Python, Node.js, or Go, we have native clients for you, right? And actually, those are clients that are supported by Confluent, so you can actually raise tickets for support. Connectors. We have a bunch of connectors that we kind of productize it. And if you want to have, for example, native connectivity with BigQuery, there's a connector for this, right? If you want to store data on Google Cloud Storage, there is a connector for this. So all of that makes you, as a developer, shorten the time you would have been spending creating and implement your projects. So that minimizes your risk, your technical debt, right? And lastly, we also provide a lot of cool things like KSQL to do string processing. And I'm going to be demoing this in a moment. You're going to get to see how KSQL works, how it looks like. For those of you that never heard about KSQL, I am confident that you're going to like it, right? Especially if you are a developer that has been developing Kafka Streams. How many of you have heard about Kafka Streams, the Java or Scala library? So Kafka Streams is a way to implement string processing in Kafka, but KSQL is a much easier way to implement that. So that's part of our subscription as well. As well as we have a lot of Docker containers, Helm charts if you want to deploy Kafka on top of Kubernetes. And of course, we have Terraform scripts to spin up VMs with all these things in whatever cloud provider you want it. So that's the value that comes with Confluent Cloud. It's not just manage Kafka service. So I would like for you guys to keep that in mind. Besides this, it is very easy to work with Confluent Cloud. And I'm going to be showing right now how that works. So I know that some of you might be thinking, OK, right, talk's cheap, right? Show me the code. And I'm going to spend the next 3 minutes. And within these 3 minutes, I'm going to create a cluster in Confluent Cloud. I'm going to create a topic on that cluster. And I'm going to create producers and consumers to read data and write data to the topic. Then hopefully, I will be able to do this in 3 minutes. So all right, let's do it.
You switch to the demo machine, please. Thank
Good
you.
point. All right. So let me put this aside. And I am in my workspace here? Yeah.
Yeah, that's you.
All right, so that's me. So what I'm going to do now is log in into Confluent Cloud with my account that I've created before. So I'm going to be providing the link later so every one of you can sign up for Confluent Cloud and spin up your clusters. I think we are in the wrong window, right? Because maybe the wrong browser.
Let's do this.
Yeah.
The joy of sessions and sharing login.
The beauty of doing demos alive is that the audience gets some fun as well.
Don't tell anyone that we're using Safari.
Exactly. But it only was in Safari. So where you're looking right now, it's we have this concept of environments. So when you are creating your clusters, you want to separate them in dev, prod, QA, or you maybe want to separate them by lab, right, line of the business. So I have an environment here that I created for myself. And within an environment, you can create not only clusters, but also schema registry, which is another component that's very useful when you're developing Kafka applications. Schema registry, long story short, is where you can store your schemas. And currently, we are providing support for JSON, protobufers, and Avro. So wherever you want to serialize your records using one of those technologies, it is supported by schema registry. And more importantly, it's part of your subscription. So it's a managed schema registry server that you don't need to set up by yourself, which is pretty cool, right? So let's go back to the cluster tab, and I'm going to create a new cluster. And I'm going to call this cluster, for obvious reasons, I'm going to call Google. Too many O's. Google Cloud Next 19, right? And it's interesting because we made it very easy for people to size clusters. So basically, we ask 4 questions for you. What's going to be your write throughput in megabytes per second? What's going to be your read throughput in megabytes per second? What's going to be your storage necessary for that cluster? Because as you know, Kafka is persistent. All the records that's flowing in through Kafka end up in the disk. That's why we need storage, all right? And in the end of the day, you also get to choose which cloud provider, how do I scroll down? Right here. This window probably can, OK, good. You also get to choose which cloud provider, which I think is a good idea to choose Google for this time, right? What do you guys think? I don't know, maybe. Once you choose the cloud provider, you also get to choose what region you're going to work with. And if you want to have high availability, you can also choose which availability zones you want your clusters to be replicated. So we're going to spin up brokers on that regions, and if you want high availability, you would have 3 instances of a broker per availability zone, and they will keep in sync for you for in the event of you have full tolerance, extra full tolerance. So, and you might have seen this, that by the time you all do this, all these options, you see right away what's going to pay for it. So it's going to cost 0.54 cents per hour, which is very good if you're doing a POC. So you can simply spin up your cluster, do what you need to do, and then after that, you delete the cluster. It's pretty cool, right? So let's launch a cluster. Believe it or not, the cluster is running, right? So this is the Bootstrap server endpoint that is publicly available, which I'm going to use to set up my CLI to communicate with the cluster. But before that, one thing that you need to do is to create your own set of client credentials, because you need to authenticate yourself to the cluster to say, okay, I am authorized to communicate and produce and consume records from that topic, right? So 3 informations: Bootstrap servers, API key, API secret. So what I'm going to do, I have this guy over here, and I have the CLI from Confluent Cloud installed on this computer. We call it CC Cloud. And the first thing you do is to init. So it's going to ask, okay, all right, I got it. What is the Bootstrap server? So here is the Bootstrap server. Okay, so what's the API key? That's the API key. Oh, common V. And what is the API secret, which at this time, I don't think is a secret anymore, right? For obvious reasons. So I'm going to pass it here, right? And I'm going to put this aside. And there you have it. So we now have our CLI hooked up with our cluster. So if you type cCloud topic list, there will be no topics for obvious reasons. This is a recently created. Let's create a topic for fun. CC Cloud topic, create. I'm going to call it test. And I'm going to keep things default here, but I could have specified the number of partitions for the topic, the replication factor, and all that stuff. All right? So if you go back to our console and look through the topics option, here's our topic. So what I'm going to do now is to inspect that topic right here, and there's an option called inspect that monitors in real time all the records that are flowing through the topic, right? So this is our consumer in the end of the day, and what I'm going to do here is to produce some records. Produce minus T, where's the topic name? Test? Yeah, test. So I'm going to produce the famous that every developer loves to use as a test. Hello world, word with L, right? Hi, Carthy, sup? And if we go back to our console, here's the records. So
very cool.
That's a producer, a consumer, ready and writing data to a topic. We create a cluster from scratch, and I don't know, it has been 3 minutes.
Okay.
Less than this, hopefully. All right, so that, guys, what I would like to demonstrate here is, as a developer, you don't want to spend time managing Kafka by yourself. Kafka is a proven technology, the brokers, the cluster itself. What you want to spend time is to developing code to communicate with Kafka, right? So that's the value that Google Cloud is bringing to you as a service, all right? With that said, I'm going to hand back to my friend Carthy, and we're going to carry on the presentation.
Thank you. Can we switch back to the slides? Thanks. So before I get into my demo, I want to spend a little bit of time setting up the context here for the demo. You saw how easy it is to stand up a cluster. When I did this session last year, I had to stand up my own Kafka cluster. It was not fun. This is so much easier. Yeah. Now we can get into how we actually do processing, right? So here I've cooked up a kind of a contrived scenario meant to highlight the goodness you get when you bring together Kafka and GCP. So one thing that I see a lot when I talk to customers is they've had a number of applications that they've been building over the years that they've deployed on-prem. Now they want to take advantage of GCP. These may be applications that use OLTP databases that generate a lot of data that would be interesting to analyze. So when they go to GCP, they'll deploy new applications that are cloud native, that are also generating their own potential analytics data. Analytics doesn't care where the data comes from. You just want to be able to analyze, over all of your applications and see, what kind of trends emerge, et cetera. And one possible way to approach this when you're doing streaming analytics is use the power of Dataflow and the ability that Dataflow has to pull data from different sources to then generate analytics, cross-cutting analytics across applications. So what we're going to do here is we have the on-prem application sending data to Kafka that's in GCP, like Ricardo just showed you. Ricardo's actually going to go into more details on how you can set up Kafka Connect, as illustrated on the top left there. We won't talk about that right now. We're going to assume it's, well, not assume, I've actually set up a Confluent Cloud Enterprise Kafka cluster already that I'm sending data to. And then I have a pub/sub topic that I'm sending data to as well. And with Dataflow, I'm going to combine those two streams, merge them, and then write it to BigQuery, which is our serverless data warehouse. And then we can do some queries against that data that's in BigQuery. So that's the goal. Before I switch to the demo, one other thing I wanted to mention is I have this rather unglamorous application. I'll let Ricardo do the cool demos. This is essentially a loan processing application that takes requests coming for loans and decides whether to approve them or reject them. And the only field of interest here is the credit score of that user. As you'll see in the code that I'm about to show, we'll look at the score and say, hey, if the score is below 700, then we're going to reject the user. If it's above 700, we'll approve the user. All right, now let's switch to the demo machine, please. Awesome. Yeah, I'm actually going to jump to the code right now. Actually, before I jump to the code, let me actually mention one other thing. How many Java developers in the room? How many people have actually used Java? Okay, quite a few. Awesome. And the reason I ask is there are a number of built-in I/O transforms that Apache Beam, the thing we're going to use to do this processing, unified processing. Beam, for Java, has a Kafka I/O connector. In the Python world, the Python I/O connector is still being worked on. It's not available yet. In addition, for those of you who attended the new, DA311, the new announcement that we made about Dataflow SQL, you could use Dataflow SQL with Kafka. It's an experimental stage right now. That's actually why I'm not going to demo it. I'm not brave enough to do that, but strongly encourage you to play with it. You can do some of the things that I'm showing you now. As soon as this matures, you can do it in SQL in the same way that Ricardo's about to show you how to do in KSQL. So SQL makes life a whole lot easier for a lot of analytics. With that said, let me jump into the Java code here. I've actually got this deployed already, but I want to talk through a couple of important aspects. So this is my main class. Once again, not creatively named. Essentially, I'm merging the pub/sub and Kafka streams into one stream and then writing that to BigQuery. And the thing that I want to call attention to is I'm using the Kafka I/O Beam connector, and I'm specifying some of the key attributes that Ricardo showed you earlier that I pulled from my Confluent settings. Do all of that there and write everything or pull everything into something called a P collection. In Beam, this P collection is the thing that you do transforms against. You can do a lot of interesting things. In this case, all I'm doing is, before I write the data to a P collection, all I'm doing is checking to see if the credit score is above a certain threshold. If it is, then I let it pass through. Similarly, I'll do the reverse on the pub/sub stream, read data from a pub/sub subscription, decide if the credit score is below a certain threshold, and then let that through. And this is the code here, or the transform, I should say, for merging the two pipelines. You can see it's idiomatic Java. It's very easy to follow, except for all this stuff here. And then I turn around and write it to BigQuery. And when I do this write to BigQuery, I'm using something called a streaming API for BigQuery, which actually lets me do SQL against the data that's being written to BigQuery in near real time. And I'll demonstrate that real quick. And that's actually an interesting scenario because simply by virtue of writing this data into BigQuery, I can do SQL analytics. You know, I'm just doing it in BigQuery, that's all. So I've got this table. It's called Merged Credit Applications. And I'm going to query that table. I'm just going to do a count for.
So just for you to know, while Karth is typing the code, we have this producer running on a GCP VM that's continuously sending records to our pipes, and those records are being streamed using Dataflow, which in turn end up in BigQuery. That's what Karth is going to query right now.
Right. Thank you. Yeah. So you see that it says 408. And when I run this query again, and this is happening in near real time, the count has gone up. So you can actually do more interesting queries against this data as it's being written into BigQuery. So it's a cool integration opportunity that you get when you bring Kafka into GCP. A couple of other points that I want to mention real quick. Customers have gotten are really excited about using Dataflow and Beam against Kafka. Two gotchas to remember, and that is on the networking side. When you deploy Kafka with Confluent, you get a peering relationship. This is for the enterprise edition, right, Ricardo?
Yep, that's correct.
Ricardo's going to cover that in more detail. When you write a consumer that consumes data from this Kafka cluster, you have to make sure that consumer is in the same VPC that is peered on your side. If you don't validate the connectivity, you'll run into a lot of issues on the Dataflow side. So a couple of suggestions that I have to validate connectivity is once you have the name of the Kafka cluster, let me just grab this real quick. My mouse will cooperate. So that's the Kafka cluster that we've deployed. And what I'm going to do is essentially, I'm going to log into a VM that's running in the peered VPC that I mentioned earlier. Once I've logged in, I recommend first telnetting against 9092. That's the port that Kafka gave me. And you can see that I was able to connect. So that's one. And another suggestion that I have is actually trying to validate that you can use the Kafka consumer. And I'm actually not going to run it right now because I think we're running short on time. But as opposed to the C-Cloud approach, I would recommend just using the Kafka consumer that comes with the distribution and validate that you can talk to the topic. Now, the last piece of or the last takeaway from this when you run Dataflow against Kafka is, since we're talking about Java, you're going to use Maven. You're going to specify the network that your Dataflow job runs from. This is very important. If you don't do this, Dataflow is going to kick off in the default network, and that may not be the peer network that you set up. You can also specify the subnet. So the networking aspects of this are important to keep in mind, in addition to obviously specifying that you want the Dataflow runner. When you kick this off, for people who are familiar with Dataflow, if you kick it off from your local machine, which is what you may do with a lot of Dataflow jobs, the local machine cannot see the Kafka cluster usually because there's no path to the Kafka cluster. And this is the error you'll get. It'll say timeout expired while attempting to fetch topic metadata. And the way to ensure this doesn't happen is, once again, create a VM like we did here, the same VM that you maybe attempted to telnet from, and kick off your Dataflow job from here. So keep all of that in mind, and hopefully you'll have fun playing with Dataflow and Kafka. So with that said, I'm going to hand it back to Ricardo. Back to the slides, right?
Yep. Back to the slide. Thank you. Thank you, Karthi. What I'm going to do now, it's a two-steps process of showing you how to do KSQL processing, exactly doing the same thing that Karthi did with Dataflow and Apache Beam, sending data to BigQuery. But in this case, what we're going to do actually is do string processing and then sending data to a Google function using Kafka Connect and KSQL. But why I said is the two parts, because I want to set the stage first so you have a better idea about how KSQL works. So we're going to do a quick demo about KSQL itself. And after we run into the demo, I'm going to show you the other demo, which is actually doing exactly what Karth did, but using KSQL and Kafka Connect. All right? But first, let's talk a little bit about KSQL. And the way I would like to showcase this is to using mobile phones for producing records that are going to be processed using KSQL, right? So in order to demonstrate how we're going to do this, I'm going to do this with my friend Karthi first, and then once you see how this works, you guys are going to get to produce the events using your mobile phones, which I think is going to be real fun. So where is the terminal? Actually, can we switch back to our demo? Yep, thank you, sir. All right, so
actually, let me get you to your workspace.
Yeah, go ahead.
Ricardo is new to Macs.
Yes.
I don't blame him for having difficulty.
I am a Linux user in a Lenovo laptop, so it's kind of hard.
And I'm going to try to pull up your client app here.
Thing. All right. So what I have here is a KSQL client installed on Karth's computer, and I have a KSQL server running on GCP. KSQL server is where you deploy your KSQL queries, right? Simple as this, right? So in this KSQL server, I have, if we type the topics, you're going to see all the topics that we've created for this Kafka cluster, but we also have the concept of streams, which basically are abstractions on top of topics, right? If we describe the stream, which is basically describe the metadata about this particular stream, you're going to see that this stream actually is based on Avro, so that's the format for the records that I've been working on for this demo. And it has a complex data structure, like it has a name field and two child fields called motion and speed. And within those columns, let's say columns, we have child attributes. So that's one of the powers that KSQL brings to you, because you can actually handle data structures that are non-trivial, are not simply flat tables with columns, right? You can actually deal with complex data structures, complex objects coming from whatever you're serializing, like protobufers, Avro, or JSON. So what I'm going to do now is, Karthi, you have the application running?
I actually don't. What was the URL again?
All right, let me type it for you. No worries.
Thank you.
So we have this URL running somewhere. Expose it in a GCP load balancer. You guys are going to see it, no worries. Web app. Should be this. Yep.
There you go. Now I'll do the rest.
All right. So he's going to start moving his phone with his hands, of course, right? I'm going to execute the square right here. And what you should see here is all the events coming from his phone. He's going to type his name, and all his gestures and movements from the phone are going to be populated the variables x, y, and z. Here you go. So that
was harder than it needed to be, but it is working, yes.
Yep. So let's try this, Carly. If you close your browser now, let's see what happens with the KSQL console. So the event stops because it's actually real time.
Just don't ask me to bring up the app again, because that was hard.
You forgot the URL. I know it. Yeah, I got it. So let's do this. I'm going to left the query running with one small change. So I'm going to interrupt this query. And you saw that I've selected everything first, right? So let's do this. I'm going to basically show the name, the field motion, but with the attribute x as x, the field motion and the attribute y as y. As y is kind of a weird, right? And motion and z as z. So I'm going to make things simpler. And my friends in the back, could you switch back to the slides, please? And what I want you to do is to grab your cameras from your phones, scan that barcode over there. It's going to pop up a URL where you're going to see the application, right? type your name or nickname or whatever you want to be called.
Something nice.
Something nice. Don't be rude.
Because it's going to show
It's
up.
going to show up here. And then when you click play, you're going to see a cube that moves with your hands, right? A quick disclaimer for some of you that uses iPhone, specifically with iOS 12.2. It's not going to work. Not our fault, Apple's fault, right?
Okay, now could you switch back to the demo machine?
Actually, just a second. Can you switch back for the slide first? Yeah. If you are an Apple user, go to our Safari settings, all right? Settings, Safari. There will be this toggle right there. Now they make it optional to use for any application to access the accelerometer of your API. So now you have to check it explicitly in order to work. If you do that, that's a workaround, and then you can come back to the application. It's going to work. My friends, now you can switch back to the demo. So yeah, we have a couple names popping up right there, test. For those of you that uses Android, it's going to work right off the bat, so not sure why, right? Cool.
We're going to rerun it, see what
Yep.
happens.
Well, it should be popping up some events right now, but let's see.
Probably where it was working, but only I could see it.
Yep.
Because he told me to switch it back to the slide.
Yeah. Probably it's kind of going through the satellite, going back to Earth, and then the internet connection is kind of an
But you get the idea.
Yeah, you got the idea. That's at least we have.
There's a
your name.
proxy involved that we did not necessarily beef up before it gets to Kafka. So, yeah. But anyway, you get the idea. It gets to Kafka.
Exactly. So let me stop this. Everybody got the cube moving with the iPhone? Well, at least one thing you learn with this presentation, like how to enable the cube in your phone. So that's cool. Right, so presentation, please. All right, so that said, let's actually take a look. And I'm going to go back to what Carth did originally. And I'm going to show you how that will be the implementation. Now that you learn how KSQL kind of looks like, it's a query, right? KSQL is simply an abstraction that we created on top of Kafka Streams, right? So we have the concept of KSQL servers that you spin up wherever you want, Docker, Kubernetes, Neighbor, bare metal, whatever you want, and you deploy queries. The only difference between those queries for a typical SQL query is that they are continuously running, right? So once the records are coming in, KSQL process them as they happen, and the output of those queries are going to be flushed out to a topic that someone can consume it or send somewhere else, right? So let me show, okay. Yeah, thank you. We are in perfect sync about. All right, so it's Safari or Chrome?
That's Chrome, yeah.
All right, Chrome. We have this guy called Control Center that is a monitoring tool that comes with Confluent Cloud. It's free to use for wherever has the subscription for Confluent Cloud. And as you can see here, we have this topic that Carthy was using before that was getting all these events from this producer that is running somewhere, right? So that topic is continuously receiving all these credit applications. And we have this field called credit score right here. So what I did in this implementation was effectively using a couple streams on this deployment. So the first stream I created was what we called wrappers. Wrappers is a way, as the name implies, I mean, you have to come up with a representation of your Kafka topic to KSQL. So the best practice is always create a first wrapper. So it's going to be your, like if you are in ETL processing, that's going to be your first data stage, right? That's the wrapper. After this, I created a streams that you can basically describe all the fields right here. And actually, there's a better way to describe this, which is running a query right off from Control Center. So I'm going to describe, sorry, extended applications. I think I put in plural, stream. And I'm going to run it. If you do that, you have access to the actual sentence about how do I create this. So KSQL language, create stream applications, approve it with, we can change the format interchangeably between JSON, Avro, protobuffer, CSV. So that's one of the beauties of KSQL as well. And as you can see here, I'm basically querying the applications wrapper, right? So how do I minimize a little bit so we can see everything? Okay, good.
Like that?
Yes, yes. And probably make it worth for you to read everything, but I want to show you the where condition clause over here. But what's interesting about this is not only the wrapper, but this query right here that I call it applications rejected, right? So applications rejected is, let me...
Big question, is that really small in the back?
Yeah.
I think we should make it a little bigger.
Bigger, right?
Yeah.
Let me just run this and you can increase the font. All right, go ahead.
Fortunately, when we connect it to the monitors, it reduces the resolution.
Yeah. So let me scroll down a little bit so you can see the results of this query. So I created a stream called rejected alert that basically queries the previous streams. So not sure if you're getting the feeling here, but when you are creating streams, you are creating a chain of processing. A stream that produces results that can be queried by another streams that produces results, just like ETL pipeline, right? But in this case here, we're actually querying a applications rejected stream, and we're creating a window tumbling. That's pretty cool, because within that result, we can specify a window of 1 minute, 1 hour, 1 day, 1 week, and all the query are going to be applied to that window. And we call it tumbling because that windows keep moving all the time and always generating new outputs and new records, right? The output of this, right? Every time you create a stream rejected alert, for example, in the end of the day, you are also creating a new topic. So the name matches rejected alert. So if you query this guy, you're going to see all the records that are coming in. It's been filtered already, right? And I am pretty sure that since they have been rejected, the credit score is going to be always less than 700. Because that's the where clause that we created, where credit score is less than 700. So we filtered the stream and produced an output that is being sent to this topic, right? All right, so we produced records, we did the string processing, and what you can do with it, what useful thing you can do with it? You can use Kafka Connect, where you can set up sources and sinks. In this case, I'm creating a sink, right? So I'm syncing into something. I'm willing to grab all the records from that topic and send somewhere else. What I'm doing here for this connector specifically, let me show you the details of it. You see that I'm reading from the topics rejected alert. So this stream is being, the result of this stream is being sent to this HTTP endpoint, which happens to be a Google function. So what we are doing here is actually grabbing the result of the string processing and calling a Google function using HTTP as the technology enablement for sending the results to it. So Karthik can show you the dashboard where you can see all the Google functions being called and the throughput of it. So
everybody know what Cloud Functions are? Essentially, it's our serverless,
yeah, that's
essentially
good question.
Way of running code. It's been around for a little while.
Yep.
And I wrote a Cloud Function that took me many days to create, which is why it looks this simple. It's called Hello HTTP, and
yeah,
it has
very creative.
All it has is essentially some code that prints out the payload that you pass into it. But the key here is you can see that, you know, what Ricardo did, which, by the way, the highlight there is it is a little bit different from analytics, right? When you're doing analytics, you can use Dataflow or KSQL or Kafka Streams.
Yep.
But here, you're trying to take some action. As a company that may be processing credit card applications, you want to see if you're getting more rejections than you're comfortable with, over a window. In this case, the tumbling window was 1 minute.
Yep.
If you do, then you want to take some action. You can do that by calling this Cloud Function using KSQL and Kafka Connect. This Cloud Function could send an email. I could have set it up, but I didn't want to show you my inbox. But you can do the rest. You can use one of many suppliers like SendGrid to generate an email or call into ServiceNow or something like that. So the integration is pretty cool.
Cool.
Back to slides?
Yes,
Thank you.
please. All right. So we've seen how this works. Let's talk a little bit about some best practices about how to use Kafka with Confluent Cloud effectively with GCP, right? So there are two biggest scenarios that we usually talk to customers when they're planning to do Kafka implementations on top of GCP. The first one, we call it hybrid cloud. How do we call this hybrid cloud? Because you already have a lot of Kafka cluster running somewhere in your data center on-prem, maybe your own servers or some co-located data center that you hired to host your applications. And your plan is eventually get into GCP, right? So what is the plan here? The first step is actually create a Confluent Cloud cluster, right? And you saw that it's pretty easy to spin up one. And there is a technology called Confluent Replicator that comes with Confluent Cloud that you can use it as part of your subscription. It's there for use it. You don't have to buy anything else. For those of you that come from Kafka background, it's built on top of Apache Mirror Maker, right? Essentially, it's Apache Mirror Maker, but with some enhancements to ensure reliability to deliver of the records when they are replicating. For example, if you are relying on actually, if you are using some non-reliable links to connect your data center to Confluent Cloud, you might have network hiccups, or you might have network outages, right? So what Confluent Replicator does is ensuring that data that is in motion will be reliably delivered, even though you have outages, even though you have hiccups, right? So it's ensure ordering, it ensures consistency. So the plan is move all the data to Confluent Cloud, so it's as long as all the producers and consumers are reading and writing data to your data center customers, data center applications, that data will be moving up to cloud. And eventually, when all the data is there, you can simply bring your producer and consumers to GCP, wherever you want to host it, Docker containers, Kubernetes, bare metal, you choose, and then you repoint your consumers and producers to Confluent Cloud Cluster. So that's basically the plan when you are moving workloads from on-prem to Confluent Cloud, to GCP, sorry. The nirvana for everybody that's working with this technology is to do cloud native. What is cloud native? Is when your Kafka cluster kind of born in GCP. Why is it nirvana? Because you don't have to do this whole migration process, right? And when you do that, Karthik kind of touched base a little bit and a couple minutes ago about how do we do this communication between the Kafka cluster and the producer application. So long story short, we're probably running out of time in a couple minutes, but long story short, what you have to do is, once you provision the cluster within GCP, your applications, producers and consumers, will be running in your own VPCs, right? That's the best practice because you want to isolate your workloads. You should be able to treat your Kafka cluster just like you treat a database. It should be running on your own VPC, private subnets, not publicly available, and is protected, right? So what you do is to request a VPC peering. So what we're going to do is ask two questions. First one, what is your project ID from GCP? Second question, what is going to be your network ID? With these two informations, we can do the peering for you. That's what we did for this demo. So we have a Confluent Cloud cluster running on GCP, and Karthik, it's kind of running its VM on its own project that we peered with the Confluent Cloud cluster, right? So that's the plan for having this communication. You don't want to have your Kafka cluster publicly available for security reasons, right? That's not good, all right? Lastly, Confluent is available everywhere. I mean, the plan, of course, is to have Confluent Cloud running natively as a first-class citizen on GCP. That's what we recommend as a best practices. If for some reason, maybe a personal desire, maybe it's a regulation that you have to comply to, you need to have Kafka running on your own data center within your constraints, you can always download the bits and install by yourself, right? That's what we call co-located data center. You can actually have your data center hooked up by network features of GCP, and you can have this communication back and forth from GCP to your data center. Or, better yet, if you want, for some reason, use another cloud provider, such as, I don't know, AWS or Azure, you can also have Confluent running there, and you can use Confluent Replicator to sync up all the data between the regions or different cloud providers. So the most important thing here is that we provide options. That's the beauty of the partnership that Confluent did with Google Cloud. Provides you, as a developer, the options for doing that. That said, guys, I highly encourage you, if you scan that barcode, it's not going to be the game again. It's basically, use that barcode for sign up for Confluent Cloud if you want it. You saw it in the beginning. It's very simple to create a cluster and start using Apache Kafka. There are going to be some videos on that link as well that show you everything that we show it here. And be fun. I mean, stop the struggling. Come using it as a service. Right? That's the recommendation we have for you.
Oh, thank you. And thanks for coming. Please, please submit feedback. We would really appreciate it. Yeah, and thanks again for attending the very last session.
Yeah.
And have fun.
All right.
Bye.
Thanks, guys.
There's nowhere else you wanna be.
Well, it's a wrap. On behalf of the Next Live Show crew, thank you for hanging out with us the last 3 days.
We had a great time sharing the Google Cloud Next 19 experience with you.
But it doesn't end here. Everything we've live streamed, the keynotes, the recaps, the Next Live Show experience, and all the sessions at Next will be available to watch, share, and rewatch on our video on demand page at g.co/nextonair.
Next 19 is about to go global as it heads to Tokyo and then London later this year. Follow us at g.co/cloudnext to stay in the know. So long from San Francisco.
Thank you so much for watching.
And we'll see you next year.
Long's gone, but I'm ready to go. I'm not old, but I'm weathered more than you know. I let go. We run. We go. To places we've never been. Cross rivers right out the ledges. We run. We go. There's nowhere